It looks like working.
Yeah, 1 second. Yeah, I think I did it. I got the link.
Perfect.
Can you see something there in Zoom chat?
Yeah, I can see Nikolai. The image is great, and I can see myself.
And I can see YouTube link.
Okay, so let's start the webinar. So let's
Yeah, 1 second.
let's allow people
Yeah, I
in.
think I did it. I got the link.
And I'll share the link in Telegram and WeChat. Okay.
Just give me 2 minutes. I will prepare my tea and something like that.
Sorry, a little bit Russian language in our chat. Леша, мы транслируем все на русском, да, Максим? Для Максима, ну, прости, просто транслируем. Решаем, что все проводим, да?
Да, все работает. Трансляция на YouTube работает, ссылочки работают для иностранцев, для нас не работают.
Ага, все, хорошо. Все, Максим, тогда вот так. Sorry.
Okay, so I start the webinar, let people in, and I'll share the links.
Yes, thank you.
Так, мы уже начинаем или чуть позже?
Не, мы в 12 начинаем. У нас же в 12 начало. Мне кажется, мы можем всех попросить проверить слайды, ну, как бы шеринг. Ну и все.
Да, тогда пойду тоже сделаю чай.
I don't really understand why my name is in Russian, because my Zoom profile actually has my an English name. I mean, using Latin, not Cyrillic letters. Probably.
I can rename you 1 second.
And Alexei also.
Okay. Better?
Yeah. No, it was fine, but probably it's not really useful for other attendees.
I see that Amos Bird has some issues with Zoom. And today we experience multiple issues, so we'll see how it will go. The talk from Amos Bird is not the first, so it's not a big issue. At least it works for ourselves. And we will see if people will be able to join.
In 10 minutes.
Okay, Ivan, did you post the link everywhere?
We need
Yes.
William to post it on most of the chats groups.
Okay.
And I'm not sure if he's online. And for everything else, I'm almost done.
And don't forget about Slack channel. By the way, the website that is named Down for Everyone or Just Me continues to tell me that Zoom is down right now. So the question is, it is down from what regions? At least it does not work from Russia. So Zoom itself does work, but the links and Zoom website has some issues, and it started to worry me.
We got the first attendee, so
That's fine.
not so bad.
But the question is, were there any problems joining our links? Natasha, do you have personal link for Amos Bird that is not from yandex.zoom.us?
Okay, I will ask Maxim now.
Okay.
He can join using normal link and we can promote him. So it's not really necessary.
Okay, now I see that Amos Bird has joined. And if everything will go all right, we will start in about 10 minutes.
Yes.
I see that at least some people was able to join, and I see some already familiar names. For yes, I remember your contributions, and welcome to ClickHouse Meetup. Also, I see some people from ByteDance. Welcome again. And let me remind you about the rules. So today we have Meetup in Zoom. There are some glitches in Zoom, but it seems to work. Also, we have translation on YouTube. If you can go to YouTube, that's perfect. If not, just stay and watch us in Zoom. If you want to ask a question, you can do it online. Just press a button that is named Raise My Hand. I will unmute you and you can ask your question. You can ask your question online. So our meetup will start in about 5 minutes. And today we have 6, if I count correctly, 6 talks. So it will last multiple hours. We have presentations from ClickHouse developers, from community experts. We have talks from people from the industry. We have lightning talks. So get yourself ready. Today Meetup is the second ClickHouse Meetup East. The meetup that is dedicated specifically to Eastern Asia. But if you are not from Eastern Asia, does not matter. You can still join and watch our talks. Today we will discuss the most fresh ClickHouse features from this season, summer, autumn. We will discuss some community contributions. People will tell us about their experience in their companies. So I see that there is already quite a few, or not quite a few, but enough attendees. We will have about 3 minutes before we will start. You still have about 3 minutes to invite your friends, to invite your colleagues. And also you can try to raise your hand. We still have some time for the first questions before the meetup, if you want. So let me present our first speaker. Our first speaker is Nikolai Kochetov from my team. He is one of the legendary ClickHouse developers, one of the most prominent developers from my team. So welcome, Nikolai.
Yeah, hi.
And Nikolai will tell you about one of the most new feature, explain query.
Yeah, sure. Today I will tell you about explaining ClickHouse. And let's start the presentation. So first of all, I would like to tell something from history. When users ask us, like half a year ago, if it is possible to get some explain or query pipeline from ClickHouse query, we usually say yes, it is possible. But in order to do this, you need to go to the server, find some logs, grab your query, and see something like you can see in the slide, query pipeline and several steps we need to execute. And this worked until release 23. After this, ClickHouse started using a new pipeline, and this message has escaped. And actually, it was possible to see it in logs still. If you enable special setting experimental use processors equals 0, it will switch to ClickHouse into old pipeline, and this message will come again. But from release 20.5, we have removed this old pipeline, and this setting does nothing. So there is no way to see even such simple message in logs. So in order to fix this problem, we have added a new explain query, which simply works the same way. If you write explain, we can also add special setting description equals 0. You'll get almost the same output you've seen in logs. And at this point, I could have stopped my presentation because it just works and you can use it. But actually, it happened that explain has a lot of different types and features. And I would like to show it to you and discuss what we can achieve from this new query. At first, we have 4 different types for explain. 2 of them explain query syntax, and the last 2 tell us about pipeline and query plan. And some of types even have special options. So let's check every of them and discuss. So the first one is explain AST. This query shows us how abstract syntax tree for query looks like. And this feature may be interesting more for developers than for users, but it still may be useful to understand how query is parsed. And for example, if you implementing some ClickHouse external driver, you can do the same thing as ClickHouse client does. Exactly, you can try to parse query and understand if it is correct at all. So this may be not very interesting, but next query, explain syntax, is pretty useful. Explain syntax shows us how ClickHouse write query and applies different syntax transformations and optimizations. And there are a list of possible optimizations, like ClickHouse can push down predicate on AST level. It can substitute aliases, but I think the most interesting feature is to see how join looks like. So when you join multiple tables in one ClickHouse statement, like here I join tables A, B, and C, ClickHouse actually do not execute as whole. It writes query as joining table A and table B in subquery, and then joining table C to this subquery in final. So actually a query is written, and it may be important because ClickHouse does not optimize table orders and select and in join, and it is executed as is. It means for this case that we read in streaming from table A, and tables B and C are stored into memory. So it's better to try to use tables of the right part as small as they can be, and big table should be left. Let's go on. Next type is explain plan, and this is a default query. If you do not type plan, it will show you the same thing. So plan is just a tree of basic steps we need to execute pipeline. And to demonstrate how it works, I have used a pretty simple query. In the slide, you can see that we read from table function numbers, first 10 numbers, then group by number oddity, and calculate sum for numbers per each group. Else execute function +1 and rename column to x. And so let's understand what explain plan shows us. First of all, by default, it shows steps with description. And let's read it from the end. At first, we need to read from storage, some list of columns. And in this case, it is reading from storage system numbers. You can see it here. Then we need to execute expression before group by. And this expression calculates keys which is needed for group by, especially it is number mod 2. Next, we execute aggregating. We calculate sum of numbers. Next expression adds 1 to result. And the final one, projection, just renames column to name X. So that's interesting information, but there are some details I would need to tell about explain plan. First of all, it may not look like some explains you have seen in other databases. For example, it does not show you cost estimation for each step and for the query as whole. This is just not supported for now. It is probably one of the to-dos. And another one to do is to implement something like explain analyze, which first start query, execute it, measure time for each step, and show you this time in the result. It may help to understand which step of query is the longest one. So also, as I said, this type of explain has several different settings. And when I described the read from storage step, I told that we read from list of columns, but we don't see which column do we use. And it is actually easy to fix. It's easy to get this information. We can add option header equals 1. So if we write like that, after every step, we will see special message. That header contains, like in our case, after reading from storage, single column, number of type uint64. Then when we calculate expression before group by, it contains already 2 columns, number and modulo. And so on. For every step it is written, like in the last step, we have only 1 column X with type uint64. That's cool. That's useful information. But it may be still not enough. We still may not understand which step exactly does what. And to get more detailed information, we may add another one setting with name actions. So if we write explain actions equals 1, for different steps, we get different explanation. For example, expression step shows us which functions are executed. To calculate group by key, we first add the constant column 2, then calculate function modulo, and then remove this temporary column. Or for example, when we execute aggregating, we can see different aggregation keys, aggregation functions. For this query, we calculate sum of numbers, this function signature, argument types and result type, and names and positions in header for each column. Well, that's all for explain plan, and let's move to the last type, explain pipeline. First of all, let me tell about what pipeline is. Actually, pipeline pretty similar to query plan. It tells some set of execution steps, but now it's not a tree, it's a graph. It may be general graph containing loops and many edges. And nodes of graph do almost the same thing, so that every step of query plan can generate several nodes for query pipeline. And in the slide, I have changed query to show you a little bit different example, just to demonstrate all the features. Here we just read from subquery, calculate limit, calculate aggregate function sum. And as the result for explain pipeline, we see, first of all, query plan steps. They're written in brackets. And for each step, there are several, maybe 0, maybe many query pipeline nodes. In this example, we see that read from storage step have generated nodes with name numbers empty. What's interesting? Also, we see different numbers. We see that it's written numbers empty x32. Actually, it happened because ClickHouse tries to execute query as efficient as it can be, and it utilizes all the possible threads. And on the server I have executed this query, there were 32 different physical cores, so ClickHouse used 32 threads. And this step will try to generate 32 sources, which gets us numbers. For limit, we have different numbers. We see that there are 32, error 32. It actually means that we have only one limit node, but it has 32 inputs and 32 outputs. So why this information may be helpful? Because it may show you the place where your pipeline becomes single-threaded. And for this pipeline, it's the last resize step. We see that it has 32 inputs and single output. So after this resize, pipeline may be not very efficient. Steps after this resize will be executed in single thread, but likely for us, they are pretty simple. We just rename column, and that's all. So in whole, query is executed very efficient and uses all the threads. So that's how pipeline looks in a text output. But as I said, it's actually a graph, and it may be not very convenient to see it as text. And actually, we can generate a picture from explain pipeline output. To do this, we need to specify option graph equals 1. And we actually do not get picture, but we get a special output. We can copy this output right into .file and use Graphis to get a picture. The same picture if you see in the slide. Or we can use some special online sites like Graphis Online, which will generate it automatically for you. And in this picture, we see the same things. White rectangles correspond to pipeline nodes. Gray rectangles correspond to query plan steps. And this is compact way of viewing this graph. So several nodes can be stacked together. So we have numbers mtx32, it's actually 32 sources. And the same for arrows. If we don't like compact mode, we can also add another one setting, compact equals to 0, and then we will see a pipeline as it should be without stacking some nodes. For this query, I also used 2 threads to not see a lot of copies, but it's easy to imagine that there are no 2 copies of some nodes, but 32, or how many threads you have. So now I have described main types of explain query, and let's now try to use it to analyze query a little bit. And here I have query example. At first I create table with events. Pretty simple, it has only 2 columns, date, time of event, and some value. I store it into merge tree and sort by time. Then insert 100 million events. And the most logical query is to look at the last events we get in table. It's pretty easy. What we need to do to read time, actually in this query I use not just time, I use function to start of minute to make time more interesting. I'll say read value, sort by our time value, and get the last 10 rows. This query works. And it shows the correct result. We can see like 8/9. That's what we expect. And this query works in 15 milliseconds, which is cool. But what if we want to change query a little bit and we want time not in Moscow time zone, as I have, but in UTC? It's easy to fix. Let's add UTC parameter to function to start of minute. And result will be the same with only 3-hour shift. So now it's not 5, but 2 hours. And this query is still correct, but actually not as fast as query before. It works already for 180 seconds, which is not cool. And maybe if you are not a very experienced user of ClickHouse like me, you may think, maybe function to start of minute is very slow. Maybe converting of time zone is not efficient and we need to optimize this function. But if you're a little bit more experienced, you will find out that query, actually second query, it reads 100 million rows. But the first one reads only 900,000, which is 10 times less. And that's really the reason why it's faster, but still not clear why one query faster than the second one. And to understand it, let's look at explain result. So here I have explains for fast and slow query. And let's read at first slow one, which is the bottom. So what we need to do to read some last rows from table. First we have read from storage step, and then expression step, which calculates function to start of minute. And after that we have 3 different steps of sorting. It's partial sorting, which sort some rather big block of data. Usually it's like 65,000 rows. And we can do it efficiently into memory, probably with efficient CPU cache. Then we execute merge sorting step, which gets sorted blocks and creates one sorted stream. And these 2 steps, partial sorting and merge sorting, they are executed separately in different threads to make query very efficient. And then we need to merge these many sorted streams into one global sorting. And this is done in the last merging sorted step. Like after that we execute limit and get the result. And it's funny that these different sorting steps can even use different algorithms. For example, partial sorting in this case use radix sort, merge sorting step uses heap sort, and merging sorted use merging sort, which is logical. And that's cool. However, we may ask, do we really need to sort all the data from table? If we look at previous slide, we see that our table was already sorted by time. So can we just skip sorting and just read data in proper order already sorted? And that's actually true, we can do it, and that's what happens in the first query, which is fast. Here we only have read from storage step, which reads data already in sorted order, and finish sorting, which merge data together from different parts. And that's why this query is faster, and that's why it reads less data. And actually why in the first query ClickHouse have optimized this result, but in the second not. Actually, it is because function to start of minute is monotonic. Like ClickHouse sees that table was sorted by time, and monotonic function does not change sort order, so if we want data sorted by minute, we can use data sorted by time and just do nothing with it. It will work. But when we add time zone, it happens that ClickHouse already has no information about monotonicity. And this optimization is not applied. It's actually not a ClickHouse bug, because query still works and works correct. It's like that function is not have pretty much information about monotonicity. But we know this information, and we can change our query to make it fast. Let's just replace sorting by minute to sorting by time. And as a result, we get correct pipeline with only one finished sorting step, and it will again work fast for 13 milliseconds. So that was example how we can look at different query pipelines and try to understand what's going on, why some optimizations happen and why some other optimizations not. And this optimization example happened before we built pipeline. But some of the optimizations can happen already after we build it and change pipeline on spot. And let's look at another one example, probably the easiest one. For this example, I have used another query, which is pretty simple. I just read from table numbers, the first 100,000 rows, sort by number in discrete order, and get the last 10 rows. And this query works pretty fast. It is executed in 1 second, a little bit slower. Let's now change it a little bit and separate sorting into subquery. So our subquery now will read data and sort it, and main query will execute limit by. And this query still will work a little bit slower than a second, and we'll get the same result. Now let's change it a little bit more. Let's move our subquery into view. Now it will be a view with name numbers 100M desk, which will read all the numbers, and main query will just read from view and execute a limit. Again, the result will be the same, but actually query works now 5 times slower. And it may be at first surprising because we can just replace our view name to subquery, make some syntax transformation, and query should work the same way. But it actually doesn't happen. Mainly because view is not implemented on syntax level. It works as a table. And subquery actually looks like table for ClickHouse. But it still works fast, and the most interesting query, why not the last query is slow, interesting in is why the second query is fast. And to understand it, let's look at the query pipeline in 2 different outputs. We will use setting optimize. So here we have output of explain for this query, when the first, the left output with setting optimize equals 0, and right output with setting optimize equal 1. So let's compare it. It is a little bit different, and there are 2 main differences. At first, we have moved our limit step. If in the left output limit was almost the last one, now we have switched it with 2 different expression steps. And now limit was moved up to sorting steps. And another difference here is that for every sorting step, we have a special row limit equals 10. It actually means that our sorting steps have an information about how many rows we need in result, and they can execute sorting efficiently. It's clear that if we need to read only 10 rows, top 10 rows, we don't need to sort whole data. We may use like heap and make it much more efficient. And that's the main reason why query becomes faster. So this is optimization. and it is called limit pushdown. And it is available from release 27. Actually, for Vue, it also can be implemented, and there is already a PR which is in the review stage. And after we merge this PR into master, it will be in one of the next releases. And the last query will also be fast. There are other possible optimizations, like predicate pushdown, which is also implemented on the IST level, but it may be more useful when it is executed over pipeline. Like it is just easier and it works in a more general way. Also, there are optimizations like group by pushdown or order by lift up, but I will not tell about it. Maybe we'll tell when these optimizations are implemented in the next presentation. And that's all for today. Let me summarize a little bit. So, explain. It is available in release 26, and it is still in development stage. So output of explain can be changed a little bit. It can be more detailed in new versions, but it is already useful, and you can use it to look at your query and try to understand why one query is faster than another one. And there are a lot of different to-dos, like we can add support for distributed queries. For example, if you run explain for query which reads from distributed, you will get only one step, which is named reading from distributed. And it will be cool to get information from other shards and to connect pipelines together to get like common explain. Another feature is to explain analyze and showing some profiling for each step. And for sure, adding more query plan optimizations. So that's all. Thank you. So now I think if you have questions, just raise your hand.
Yeah, you can ask your questions in multiple ways. The most interesting will be just raise your hand and let me unmute you. You can also ask your questions. You can post your question in Zoom in Q&A section. And also you can post your question on YouTube if you are watching us in YouTube translation. So the first question, I will read it from YouTube. It is from Yanson Lee. How ClickHouse shows the query plan for distributed queries?
Yeah, I probably have already answered on the last slide, but now it shows only one step that we read from distributed table, and that's all. So there is no enough information right now, but I plan for sure to support this feature because it is pretty important to understand what's going on other shards and get the common pipeline.
So ClickHouse will just show you a part of the query plan that will happen on this specific server. It does not accumulate query plans from all remote servers.
So yeah, it is in to do here.
Okay, I hope it will be implemented. Another question, is explain syntax ready for production deployment?
That's a good question. And again, it's probably still a little bit more in development stage. And I don't think that it's a good idea to fix explain output because it can be changed. But in general, it's already useful to just understand how query looks like. I think it will be stable a little bit later.
I can say that at least explain query will not do any harm. You can use explain query. The output may change. in the future. So don't rely on this output. But you can use explain queries to explore how your queries work, and it is totally ready for production. The next question, I see that there is a question from week 1. I will unmute you. Week, can you turn on your microphone and you can ask your question online? I see your hand and I'm asking you to, okay. Week just disappeared. So about what else questions do we have? Another question is about, is explain query applicable for insert select?
Not yet, if I remember it correctly, but I think it's easy to support, at least for select part.
Yeah. But right now you can just copy paste select part and run explain select.
Yeah, insert is pretty easy actually. It just inserts in the table.
Yeah. Not so easy because actually we have parallel insert select, distributed insert select.
Yeah, but you will not likely see these cool features until they're supported in query pipeline.
Yeah. And probably on insert query, there will be multiple materialized view. So actually explain insert is pretty viable feature to implement.
Yeah, it will be cool to see in future, of course.
Okay. And another question, I already answered it, but I think you can repeat the answer online. What tool should be used to display the graph?
Yeah, so it is a basic graph viz. Like you copy output into .file, and you can do it from your like console command and get image, or you can even use some online sites, like probably graphviz.online. You will get like this screen and can copy paste output here and see this result, the same as in the picture. Yeah, the picture here.
This picture looks too pretty. Maybe real queries will be.
Yeah, it's likely that the real queries will be not so pretty, but it is useful to understand what's going on.
Okay. So any more questions? Don't worry to ask question online. At least we will listen to your voice and we will be happy to listen to your voice. But if no more questions, let's go to the next talk. Thank you again, Nikolai.
Yes, thank you too.
And the next talk is from one of the most productive ClickHouse contributors, Amos Bird. Amos Bird has made...
Hello.
Hello. Nice to see you.
Nice to see
Amos
you.
Bird has made 246 pull requests and continued. So this talk is about ClickHouse from academy to industry. So let's start.
Okay. Do I have my screen shared correctly?
Yeah, perfect.
Ah, nice. So greetings, ClickHouse friends. First, please allow me to greet my fellow Chinese in the native language.
One moment. The presentation was perfect, but right now I can see your notes and the
Oops.
slide is very small.
Okay, I
Okay,
see.
now it's perfect.
Yeah, I see. So I need to change the sharing. Do I get it correct?
Right now it is displaying absolutely correct.
Yes, but I might need to I might need to see my notes. So
Okay,
it does.
we can wait for 1 minute.
Okay.
So about Amos Bird, he is not only one of the most productive contributors, he also has contributed one of the most deep changes in ClickHouse code base that is deeply related to low levels of ClickHouse performance. And right now, he will tell us about these changes. Okay, let's continue.
Can you still see the notes?
Yeah, I can see the notes.
It doesn't work. The Zoom should have only showed the screen I share.
So if you share this screen, can you see the same from your display? Or what do you see? Do you really need these notes, or maybe?
I guess I might need to do that because I'm prepared in English. So
Okay, maybe you can share your screen with notes, but you need to slightly enlarge the part of the screen that is displaying the slides. So slides will be about 90% of the screen, and that's perfect.
let's see. Oops.
And as we have a time, we can ask another, I can read another question for Nikolai Talk. The question is, what is resize processor?
Yeah, that's a cool question. And actually, this is just the processor which just changes the number of inputs. Like when I showed you output of query pipeline, usually it was created for many threads. Like we read in many threads. So for each thread, we create special source, special expressions, and so on. But usually there is a moment when we need to concatenate together the output and send it, for example, to client. And in this case, we use resize. Like it takes many outputs, many inputs, single output. And this output can be like formatted in proper way and sent to client or used in other way.
Okay. So Amos Bird.
Yeah, it seems. Yeah, if it's can you see the full screen now?
Okay, perfect. And
yeah. Okay. I will start. Okay, so greetings, ClickHouse friends. I'm sorry for the delay. Please allow me to greet my fellow Chinese in native language. 大家好，我是郑天琪啊，今年博士毕业，就职于快手，现在做 ClickHouse 相关的研发工作啊。应 ClickHouse 团队的要求呢，今天我将用英文做那个汇报啊，各位朋友也可以用中文提问，我将尽力用那个双语来解答。So today I'm going to talk about the observations and practices when using and developing ClickHouse. So first, a little information about myself. I'm Amos Bird. I'm an active ClickHouse contributor with over 200 pull requests. And in the meantime, I also do some question answering around the ClickHouse community, such as Stack Overflow, issue lists, and Chinese WeChat groups. Recently, I also started to do some code reviews. So I'm graduated PhD students from ICT CAS, a majored in database system. Currently, I'm at ClickHouse data platform department, developing and managing ClickHouse. Okay, since I just started my career, I'd like to take this opportunity to share some of my experience in ClickHouse development and practicing during the role transition. My talk consists of 4 parts. First, I'll recap something I did with ClickHouse in my lab, of which some of you might have heard on the last meetup I attended. Then I will share my observations and practices after entering the industry. After that, I will introduce some cool features added recently with primitive examples. In the end, I'd like to share our current working items related to ClickHouse. So back in the school days, before I finished my PhD, I had played a lot of database systems. Among them, ClickHouse is the most adorable one in terms of academic research. In my opinion, it's even better than Postgres because of its modernness. I've extended it with key value support, added external Python capability, and graph analysis ability. So the left figure shows the entire framework and the system I built. And the final product is somehow a polyglot system running on a single high-end machine with some fancy user interfaces, and we named it Circle Graph. It is currently used in some projects within my lab, and I've received some interest from community constantly. Unfortunately, I don't have any connection with the project anymore, so I don't know what its current status is. Hopefully, it will be released someday. So today, I'd like to share some lessons learned while extending ClickHouse. First of all, ClickHouse is very extensible and portable. One of my favorite things is to use the programs folder to build new tools, test new ideas, and the result binary, I guess, is almost production ready. So I built some algorithms to run instead of writing from the minimum C++. It is built with minimal libc dependencies and has passed very strict checks. I've heard that it can even be run on Android with minor modifications, and it has over 40 kinds of input and output formats. And some of them are very flexible to use. We can build a web server that is directly driven by circle statements. And on the other hand, ClickHouse is friendly to use and easy to hack. The entire experience is like reading a textbook. There are 4 contributors in my labs now, and some of them are just green hands. Most importantly, ClickHouse helps solve real problems. It's still heavily used in my lab, doing text, document, and graph analysis. So the main lessons is ClickHouse lowers the barrier of learning and developing databases while gives new angles of how we think and look at data processing systems. And I'd like to quote the sentence here. So the sentence is, if some system works a little faster than ClickHouse on some degenerated query, this means that I have not yet optimized the code, and I will do it tomorrow. This is from Alexei Milovidov. This is why I keep use and develop ClickHouse. So after graduation, I was lucky to find a job in Kuaishou, which is a heavy user of ClickHouse. It means that I can keep using and developing ClickHouse, but in a more serious and professional way. Until now, I've joined Kuaishou for around 100 days, and so I'd like to share some observations on the ClickHouse setups we use and the issues we face. So I'd like to give the whole pictures we use ClickHouse. Here's the full picture. We serve millions of queries per day on tens of petabytes data and has a scale of thousands instances of ClickHouse. So some of the notable use cases are A/B testing, domain-specific analysis, such as video and CDN analysis. It's also heavily used in the perf metric monitoring. The data is generated from 2 main sources, the Hive and Kafka. We have a dedicated ETL service to load data into ClickHouse. It's either HiveQL plus MapReduce to load data from Hive periodically with pre-generated parts, and or Flink jobs to consume data from Kafka and directly insert it into ClickHouse. In both cases, data is ingested by local tables instead of distributed table insertion. And for each use case, we have a dedicated ClickHouse cluster. We provide vanilla cluster and for general and real-time support, and a customized HDFS cluster for hosting huge static datasets. I'll dig into these two kinds of clusters in later slides. And we also provide dedicated proxy service for querying our clusters. It's a homemade query proxy with a dedicated ClickHouse instance called Query Service to help understand query. The query service provides functionalities to get table and column information out of a given query and allows to check if the given partition value is valid based on the query's predicate. So it's able to route queries to the most suitable cluster. That is, some cluster might have an associated cluster which only contains the latest 3 days data, but with better hardware, such as full SSD support. And all the metadata is also recorded in a MySQL instance, and the end user can directly show tables and databases via proxy and query service. It's to some degree similar with a virtual warehousing. Moreover, we built a web service that does ClickHouse administration, such as submitting and proving table creation requests, setting up ETL pipelines automatically, and the service helps us to do better controls over the ClickHouse resource and simplify the operation of the end users. It also provides table information and ETL monitoring. Users can manage their tables without expert knowledge of ClickHouse. More importantly, it helps us to do unified auditing over hundreds of users. And in addition, we have a full-fledged metrics crawler running periodically. It checks almost every aspect of ClickHouse and its hosting system, which makes our service more reliable and also makes us more confident. That's the full picture of our ClickHouse setup. Now I'd like to talk about the two types of ClickHouse cluster we use. The HDFS cluster uses HDFS to store all data parts. Each ClickHouse instance is associated with an HDFS data node. So it is built to tackle 4 issues. First, our hardware rate card. Our machines with hardware rate card have high fault rates, and it can even lead to data loss. Second, we need more storage quota, and rate is both insufficient and inefficient. Third, some of our clusters have so many parts that the zookeeper's data size reaches 7 GB and becomes very unstable. Last, we'd like to scale out clusters more easily in certain time. Since we are also a heavy user of HDFS, it's a natural idea to combine both. So the main idea is to use HDFS as a parts delivering system. Our ETL service generates compact parts files on HDFS, and with host affinity based on a bucket to shard mapping. So each shard will associate with multiple buckets, which points to multiple directions on HDFS. Those directories are configured to have all the files stored on the shard hosts. Then we use a specialized HDFS merge tree engine to read compact parts from local HDFS files, usually via short circuit RAID. All the metadata operations are done in Cluster Manager, such as add or drop a column, part attachment, and movement. And there is no zookeeper in use. The HDFS cluster is almost static. There are no part merges or mutations. It's useful for some applications that requires fast and complex analysis of ClickHouse, while have no need to update data. And however, there are many other needs for real-time data processing and data mutations, which requires vanilla ClickHouse. The vanilla Click cluster we use contains 2 sets of nodes: worker nodes for storing the actual data, and query nodes for hosting distributed tables. We have limited the intermediate results, so query nodes won't consume much memory. and separate query from worker helps alleviate memory contention. It was based on version 19.5.5, which doesn't have JBOD support, so we relied on RAID, and it's been quite a pain to use. So I've talked about the main issues we faced when using the old vanilla ClickHouse and the motivations of building ClickHouse on HDFS. Let's do a quick recap. These issues are mainly about RAID usage and Zookeeper. Luckily, the current version of ClickHouse has many new features and bug fixes which alleviated these problems. Thus, we decided to upgrade. The new version we use is 20.8.1, and we use the JBOD feature to mitigate the RAID issues with better I/O utilization. However, the rolling upgrade process isn't very smooth, and the performance results are not as expected. I'll share my experience of how we tackled these problems. So there are three main lessons we learned in rolling upgrades. First, we need to disable DDL operations completely, or else replicated merge tree would be stuck at some unrecognizable entry, and data insertion will eventually stop. We should also prevent the new instances to become leader, or else new instances can assign merges aggressively, and the old instance can be OM killed. There is a setting for this purpose specially. In the meantime, we need to carefully disable new features to avoid data discrepancy. And I'd like to thank Alexei for helping me recover the files from broken parts due to misconfigurations. Finally, we need to upgrade query nodes first, or else the query results might be wrong. Okay, after upgrading Zookeeper, Zookeeper becomes more reliable, and distributed DDL becomes much more usable. We have plenty of disk space, and memory consumption is very well controlled. However, the disk utilization is somehow on par, or even worse than before, which is a serious regression on us. It also has bad user experience when some disks are broken. Queries will keep failing until all parts on the broken disks get scanned. So our immediate task is to optimize JBOD. We did some following stuff. First, we implement a feature that automatically recovers parts when some disks is broken. Then we diagnose the bad performance of JBOD deeply and solve the underlying issues with significant improvements. I'll describe them one by one. So the disk out recovery scheme works as follows. Each local disk spawns a disk checker thread, which gives three states: broken, healthy, or recovered. A disk checker will automatically transit disks from healthy to broken, or broken to recovered. One needs to create a recover file in the disk path to bring the recovered disk into healthy states. This is to avoid flaky disk errors. In the meantime, each replicated merge tree table constantly checks if a part is on a healthy disk and starts to recover all related parts. Whenever a query scans a broken part, it starts to recover instantly. We've experienced 5 times of disk broken events after releasing this feature in production, and there's almost no query affected and no exception reported from users. The recovering process works in a smooth and transparent way. To improve the performance of JBOD, we did some benchmarking of the different settings of disk reader head. The result indicates that ClickHouse extremely favors large reader head values. So because of its concurrent queries and inserts and fetches and merges, and ClickHouse does read at a granular level, so larger read head will gain. The setting is somehow hidden by the previous RAID setup. After applying larger read head values to all JBOD disks, we observed around 100% improvements on average query latency, especially for long-running queries. In addition, we also observed the degenerated rates among JBOD disks. This is because traditionally, ClickHouse assigned read tasks randomly to each read thread and do read stealing in a fixed order. This works in one disk setup, but fails badly in JBOD. This is especially true when running long queries in a cluster. Some of the instances will back off read thread slowly, and the last 10% of data read will somehow get clustered in a certain disk. So the phenomenon looks like we concurrently read from one disk for 20 seconds, and then switch to another one for the next second's read. To tackle this problem, we first split the read tasks evenly among threads beforehand, and later do balanced read steal. At first, we try to use random stealing, but it incurs heavy read initialization cost. Now we use a different scheme. We first check if any back-off threads can be resurrected. If no, we steal the next one of the current thread. Thanks to the pre-balanced workloads, it should have a pretty good uniform distribution in general. The experiment shows very promising results. However, it's heavily related to our data and query, so your mileage may vary. Furthermore, we notice data imbalance among JBOD disks. The average number of disks used by a long query is around 3 or 4, which is very bad. So we design a part balancer, which is especially targeted for long-running queries of some given partitions. We have also lowered the maximum part size to allow better balancing. Currently, we use a script to balance constantly in idle time, and eventually we will have an automatic part balancer over JBOD array. It's still a work in progress. Aside of JBOD optimizations, we also did query optimizations, which are mainly related to better index usage. We've observed a lot of needs with nullable types, and traditional ClickHouse doesn't allow nullable columns inside primary keys, which limits the query optimization. Sorry. As a result, we've developed a full-fledged support of nullable primary key support. Nonce are default to be greater than any other values. It's trivial to allow nullable types appearing in the primary key expression, but a bit tricky to have index condition work correctly. To tackle this, we introduced negative infinity and positive infinity as two value sentinels, and let none equals to the positive infinity. Index processing is then extended to handle the sentinels. In the future, we might need to optimize nullable types in other cases. And I noticed some issues related to suboptimal nullable processing in recent issue list. There are other index usage optimizations. For instance, the heavily used to-date functions and the binary operator with constant argument. I won't go into details, but the result is that now we have more sophisticated expressions work as index columns, and they will work correctly. Moreover, there are some constant showing up queries that are related to partitions. We've also have them well handled. Now we can instantly get row counts from partitions, and the partition pruning works in more cases. Okay, so in the rest time, I keep contributing to ClickHouse constantly with new features. I'd like to introduce some of them as it somehow gains interest in the community. So the first one is column transformers. The idea is originated from BigQuery and suggested by Alexei. It's an extension to the column matcher. Currently, there are 3 kinds of column matchers: asterisk, qualified asterisk, and the column functions. A columns function. All of them are extended to do column transformations. So I will show you some examples. So first example, we can wrap all columns in a given single argument function. We can combine multiple transformers sequentially and apply the transformation one by one. And we can also exclude some columns or replace them with new expressions. So there is a special notice about the replace transformations. We do the replacement before the S statement. So it works like we are writing x plus 1 as x to express that we are replacing x with x plus 1. Okay. So it's also possible to use column matchers and transformers in the insert statements, and it's useful for insert select statements especially. For instance, we can exclude some columns to line up columns between source and destination tables. There are also other ideas of applying transformations. Recently, I noticed a feature request to ease the effort of handwriting schema lists. Perhaps we can introduce a schema function which accepts a table object and generate a column declaration list. And this could be further transformed to suit the needs. It's still under discussion though. Another interesting feature is the untuple function. It's implemented with the help of Nikolai. Now we can create named tuple generated from column identifiers, and we can then unfold the tuple with the original names. Combined with column transformers, we can write powerful queries in a simpler and more intuitive way. So for instance, we can use argmax and untuple to achieve something similar with using standard window functions to get the top 1 elements of each group. Okay. Another feature is the traditional common table expression statement. ClickHouse has exotic support of with statements. It's used to introduce Scala alias into the current query context. However, sometimes we need to have named subqueries introduced as table objects, not Scalas. So we implement CTE, and the syntax is consistent with the Circle standard. Now I'd like to share some of the current working on efforts in Kuaishou. The first one is projections. We'd like to have better materialized views in ClickHouse, which is similar with traditional data warehouse and data cubes. The projection name is from Vertica, and basically it's a different representation of a data part. So for instance, we can have different ordered parts or aggregated parts to accelerate different queries on a single part. Another effort is to implement the Elasticsearch table engine, which is useful as a dimensional table. And we are also doing some resource management works to help make our ClickHouse service more robust. Okay, I think that's all. Thank you. If you have any questions, please raise your hand.
Okay, thank you. The first question is from me.
Okay.
What version of ClickHouse is used in production in Kuaishou right now?
There are 3 versions, I guess. The old one is 19.5.5, and the new, yes. So I upgraded to the 20.8.1.
Mm-hmm. And what is the third version?
The third version is used for the HDFS. So I'm not sure if the version still counts because it's divergent from the master branch. I think it's still based on the 90.5.5 version. Okay.
But I hope it will not diverge too much. So if you will send...
I see. Yeah. Yeah, we will consider it.
Okay. Also, we have a question in Q&A section. I cannot read it because it is in...
I see. Yeah, I will try to find it. So the QA section.
It is about Kafka and Flink. The only words I can read in this question.
So where can I find that QA section?
In Zoom, first stop sharing your screen.
Oh, okay.
Then in Zoom window, at the bottom, you will find a button named Q&A. It is
I see. Yeah, I can see that. Now, so the question is, he asked that he saw Kuaishou uses Flink to consume Kafka to ClickHouse and don't use the built-in Kafka engine. So what's the consideration? So I will answer the question in two language. 这个原因呢是考虑到多方面吧，主要是我们现在有这个 Flink 这整体的 ETL 的这个体系，然后呢还有一个就是 ClickHouse 它本身的Kafka engine，我们在使用的过程中呢遇到了不少问题，也不方便隔离这个问题去考量。这多方面原因导致我们选择了自己的一个使用 Flink 来消费写路。So we decide to use Flink because that we have a mature Flink support in our team, neighborhood team. So and the last time we used the Kafka engine, it's not reliable yet. I'm not sure what the current state is. So we use the Flink to build the ETL pipeline, and it works quite well.
Okay, and another question also in Chinese from Don Don. It is
I see. Okay. So the question is especially to me. It says that what machine learning components are used to cooperate with ClickHouse to introduce them. So the component is basic Python and Number and NumPy. So the science computing stuff. So 我用的东西呢，主要就是 Python， 然后 NumPy、Number、Matlab 相关的东西，就是把 Python 放进去了之后呢，就可以用 Python 来扩展了。当然那个整体的这个研究都是基于单机的。
But how these components are integrated in ClickHouse?
It's integrated in a way of table functions. So the Python are embedded into ClickHouse in a traditional way, like to other databases. But the data pipeline is used similar to the way that the MonadDB does for their Python UDF. So we map the NumPy array directly to the ClickHouse column array, something like that.
Yeah, I remember that we will request the similar pull request, but it was not very practical. It was not finished. So probably you have.
There are other technical issues. So yeah, possibly I will reconsider it. Yeah.
Yeah, I know there are some issues with linking of Python into ClickHouse with static linking, dynamic linking.
Yeah, and about the risk of segment fault.
Yeah, Python is not a safe, not even memory safe language. You can easily get a seg fault in Python.
Exactly.
So also, we have two more questions, also in Chinese. No, three more questions. One question is also about Flink from Zhang Xiao.
I see. Yeah, the question is, does Flink push data unreliably and lead to data loss? Yeah, sometimes. But here's the deal. So we have two pipelines. One use Flink to get real-time data consumption, and it might have the possibility that data might be incorrect. So we will have another pipeline that rewrites the same data using the Hive or the offline buckload stuff. So we will eventually get the right data. So the deal is that we just want to have the real data to become available, but in the 99% available is okay.
Okay. And the question about one guy asking you to tell about JBot more in Chinese.
OK. JBot 的这个主要是解决了两个问题， 一个是 JBoard 它本身啊，我先说原始吧。JBoard 的原始是为了解决 RAID 的这个问题啊 ，RAID 它本身的这个利用率就不高，然后 JBoard 的能够不仅带来了这个恢复的这个能力，也带来了这个读写的上限，因为毕竟可以把所有磁盘都用起来。那 JBoard 现在的面临的两个问题的，一个是数据本身有可能对 JBoard 不均匀。那么我们就需要考虑一些方案，让数据能够均摊到每一个盘上。但是这个怎么均摊，怎么定义呢？我们定义的是按分区力度，也就是查询的力度。我们认为长查询都是针对天的，然后针对一天的查询呢，我们希望这个一天的查询的所有数据散落在不同的盘上。另外一部分就是针对 JBoard 的读均匀。目前的版本呢，在 JBoard 的读上面很容易出现读的聚集。也就是说，多个线程并发的时候，会同时出现所有线程都在读同一块盘。然后再过20秒之后又读下一块盘，那么我的工作主要就是解决这两部分啊，后一部分加前一部分，然后还有一些叫 read ahead 调优之类的啊，整体的效果就是提升的比较多。当然这个也是可能根据数据的分布啊以及我们的业务场景有关啊。I think I don't need to answer the question in English because it dedicatedly asked.
So the next question is probably my favorite.
Okay.
What is the most painful problem related to ClickHouse when you are using it in ClickHouse in production?
Yeah. So from my point of view, is that we need some kind of dynamic shard or dynamic partition scheme that is able to control the data distribution or control how we merge data. So we do the ATL in a way that we need to override the partition as a unit. So we can rewrite the partition when the task is failed. However, sometimes when a user wants to quickly query the data in the hourly manner, he has to partition table by hour, and that is problematic because it generates too many parts. And we'd like to have a way that ClickHouse can somehow smartly allow to use dynamic partition schemes. So this problem will go away. Another issue I face is that we'd like to have more shards related to physical shards so that it is able to scale more easily, similar to what we did for the HDFS version, the buckets. That's two.
Okay. And one more question from me.
Okay.
What is the size of ClickHouse cluster in ClickHouse? And if you have multiple,
yeah,
what is the size of each?
So the total size is around, I would say around 1,000 machines, and we have the largest one is about several hundreds. I'm not sure about the exact number. Oh, I'm not sure. I'm about to tell the exact number, but the number is around several hundreds.
Okay.
Yeah.
One additional question from, in addition to previous question about the most painful problem. What is the biggest disadvantage of ClickHouse?
Oh, that reminds me of another question. Another problem is that sometimes we need to do distributed joins, and that's very expensive. And sometimes we'd like to have dimension tables that are updatable instantly and at a high QPS level, such as 100 QPS or 1,000 QPS of that kind of dimension table. We have sought to use that ClickHouse dictionaries, but not yet used it in production. So we are doing some elastic external table search, elastic search in external tables to try to use that to alleviate the problem.
Okay.
Yeah.
We have a lot amount of questions. So the next question is from Jason22. I cannot read it, but it is something like how
I see. Yeah.
configuration of ClickHouse cluster.
Did I just lost the connection? Oh.
It looks perfect.
Okay, so I guess okay. So the question is, how does Kuaishou scheduling or planning about the question is confusing. So 快手集群的机器配置是如何规划啊 I see. So I think the question is about how we use the configurations to set up a ClickHouse instance, such as that we use JBoard or SSD or RAID, or I guess so. So we have multiple clusters, and we mainly uses JBoard or SATA disks to hold up main data. So we have about 10 petabyte data, and we will have a SSD cluster that is used to handle special events such as the 快手1001夜 the Chinese festival, the events. So when the events is coming, we will have a completely new data written to the two cluster, and the SSD cluster will have the recent data and serve the query better because it have better machine resources.
Okay. Another question from anonymous attendee is probably to me. Is ClickHouse fast mem copy still fast? Because there are some issues that is not so fast anymore.
That's a very interesting question. So
yeah.
I'm not sure.
Maybe for me, but if you have any thoughts, please.
I don't. Please.
It should depend on your CPU. And if you have some modern CPU with AVX512 support, probably we can do better because the fast mem copy is using quite an old instruction set, just SSE2, if I remember correctly. But I did not get better result with AVX2. And for AVX, we have to implement dynamic dispatch to work reliably on old hardware, on new hardware within the same build. So it's in question if it will be better to research some other implementations or just to remove a fast mem copy and keep with glibc implementation that is different on different machines. Actually, I'm trying to avoid using glibc implementation because it will compromise ClickHouse portability. If we will link with two new glibc, we cannot run our code on systems with old distributions. And also there is an issue that if we use memcopy from glibc, it is called very indirectly. It is called not as a usual function, but as a function from shared library through a procedure lookup table. And procedure lookup table is basically just an indirect call. And why do we need another indirection? It can eat our performance when we need to copy just not so big amounts of memory. But the question remains, and we have to investigate it.
Okay.
So about more questions, please do not afraid to ask your question online. You can ask in English. You can ask in Chinese. You can understand and also help with translation. So please do not be afraid. Raise your hand and you can ask your question online. But if you cannot, just post your question in Q&A section, and we have the next question that I also cannot translate, but I can copy paste it to Google Translate. It's about batch inserts. Do you see the question from third at the
I see. So the question is 推荐每秒插入一批样数据，在每个阶段怎么控制多个应用学到同个阶段一个应用一个集群呢？一条批样数据每。So the question is a bit vague, but I think I can somehow translate it. It says that ClickHouse recommends that one batch insert per second per node. So how can we control that multiple applications to write to the same node with the same rate? Will it violate the recommendations? So 所以我们在应用的过程中并没有严格遵循这个推荐。我们一般来说是会根据这个集群的具体的负载情况来进行一些动态的调整。就包括我们刚才整个框架上面的一系列的服务，它会监控每一个写入任务的延迟，还有每一个当前 ClickHouse 集群的写入的量，还有默许的压力，根据这种方式来进行动态的调整，而不会很严格的按照某一个这个推荐的指标要求。然后同时呢，也不会是一个应用一个集群肯定是多个的，不然的话那个机器的那个资源耗费太多了。So I think I have answered the question.
Okay. The next question will be probably more easy to answer.
Okay.
How do you handle backups for your production systems?
Backups. So it's not about replications, I guess.
Yeah.
So yeah. So currently, I think that our data source will have the real backup. So like Hive system or the Kafka, and we don't have specific backup for ClickHouse. Yeah, not that I know of.
Okay. And another question about our meetup. So the question is, could we please post the videos on Bilibili? Because YouTube is not accessible for everyone. So yes, we will try to download video from YouTube and post it on Bilibili if we will be able to access Bilibili.
I think I can help with that.
Okay,
yeah.
Good. So, and we are going to the next talk. And so, Amos Bert, your talk is about from academy to industry, and the next talk is about industry. The next talk is from ByteDance. So.
Okay, thank you. And I will
Thank you
finish.
again.
Yeah, okay.
Could you please unmute? And we don't see you. You can, okay?
Oh, hello. Just muted myself.
Okay, perfect. You are the next.
Okay. Okay, let me share my screen first.
Okay.
Yeah, can you see the screen?
Yeah, now we see two slides, first and second.
Yeah.
It's better to show just single slide.
Yeah, it's a title, right? Title page.
Okay.
Okay. Yeah, good evening, everyone. My name is Liu Zhaojie. I'm from Baidang, Singapore. And yeah, today I'm very glad to join this event. Actually, this is my first time to join the DEX event. And yeah, maybe that is why I don't have the T-shirt, right? The ClickHouse black T-shirt.
By the way, if we will have any chance visit Singapore again, we will bring you a T-shirt.
Yeah, yeah, thank you. I was joking. I'm joking. I don't have the ticket because I first joined this event.
Okay, don't worry.
Yeah. So maybe let me introduce myself briefly. And I got a PhD degree in NTU Singapore, and so I joined Baidang last year, and so I have the chance to get in touch with ClickHouse at the beginning of this year. And the ClickHouse team in Baidang is quite good, and the people are also very nice. So I learned a lot from them, and I also get growth a lot this year. So today I get a chance to introduce how do I use ClickHouse to do some user group analysis in Baidang. So yeah, this is a background.
Sorry, one moment. On your screen, I can see not a single slide, but two slides. Single and the preview of the next slide. It will be better, it will be better if you will show just only one slide.
Okay. Yeah, I think maybe is it because there is some issues on the keyboard, so I just share the PDF maybe.
Okay.
Yeah, is this one okay?
Yeah, now it is great. Okay, sorry for interruption.
Yeah, now it's okay?
Yeah.
Okay, cool. Okay, so this is the outline. First, I will briefly introduce the background why we start to use ClickHouse, and then followed by some experience we use ClickHouse at the beginning stage. And last is some problem and optimizations we have done and we are working on. And actually, for me, I'm mainly, so later I will introduce, I mainly works on the shared storage part, but I will also touch some other techniques part, some other part actually in the big team. So first, I will briefly introduce the background. So so actually, for the requirement is from the business team. So we know there are for applications there can be many metrics can show how good is the business or the application. So like DAU is one of these metrics. So we can see the DAU actually consists of multiple user groups. So how to understand, for example, when applications want to do some release, how do we know what will the DAU change? So they need to evaluate the impact of the DAU when they like to release some new features. So actually this part takes some, the cost for this part actually is high. So there is a real story in Baidang. So one day when business team do a release, then they found the DAU reduced significantly. So the team need to understand why, right? So most of the business team has set up a methodology to understand those important metrics. So in every steps of the cycle, it needs the support of the data analytics platforms. So that is the basic requirement for why do we start to use the ClickHouse. So in ByteDance, there are many two scenarios. So for this two scenarios, there are different features. Like for the first one is meaning for the user group or behavior analysis. So for this kind of scenario, the query pattern is relatively fixed. And the second, and for the computation is a little complicated. And the third feature for this one is total size is very large. And in the another scenario, like the multidimensional analysis, so the query pattern is complex and on demand, something like that. And the data source is diverse, and the data model also diverse. So when we go back to the beginning, why we haven't any platform, and also so the team actually has many choices. Like we can use commercial one or we can use open source one. So but we prefer the low cost, so we decide to use the open source one. And the other one is requirements are changing and diverse from PMs and users. So we also want to some highly flexible. We expect highly flexible. So finally, the way we decide to go is the open source plus self-development. So we finally choose ClickHouse as the platform for the main 4 reasons. First is highly available. Like we know we can use replicate merge tree. And the second reason is can be extended easily, because the ClickHouse engine itself is simple and well written. So it's easier for the developers to customize. And the third reason is it can scale well, because it's multi-server and shared nothing design. And the last one also important, the most important one is user actually want interactive response. So actually the most important feature for ClickHouse is performance is quite high. So that is the main reason the team we decide to use ClickHouse. So then next I will introduce some experience when we start to use ClickHouse at the early stage. So the first, so at the beginning we are mainly using ClickHouse. So first thing we want to more users to go into the system. So the first important thing we need to solve is we need to simplify the data ingestion for end users. So we just build some tools or data ingestion service for the applications, like the data source can be offline or real time, and then we can use the user can use the data ingestion service to ingest their data to ClickHouse. Then that is the first thing. And then in the next step we have done some SQL enhancement, like we customize some SQL grammar for the end users, and like some UDAF enhancement, something like that. And we also provide some data visualization tools for these end users. And also for the applications to calculate the important metrics, of course, we use the SQL interface to do the calculation. So the overall experience is at the early stage is listed here. So for the scale at that moment, it is when ClickHouse is validated successfully in real applications, and also it can provide the interactive user experience, and also it can scale well and can satisfy and it can also satisfy the requirement of the application, the fast iteration of the application. And the last one is for the availability, and so also in the most case it can satisfy the requirement for the application for the users. So at this moment, we decide to scale further, and more and more users we started to use ClickHouse. So after that we met some new challenges. So in next part, I will introduce the problem we have met and how do we solve that. So the first issue we have met is the data-related issue. Is because more and more users comes in our platform, and the data becomes more and more. And also some tasks or some applications, they have some heavy data ingestion tasks in our system, which can impact the other service if they are sharing the same cluster. And the second issue we have met is the data is increasing very fast. So we have the limitations, the storage cost actually becomes higher and higher. So for the first issue, we involve some optimizations, like we, instead of directly insert the data into ClickHouse, like using ClickHouse to do some part merges and calculation this thing with the resource inside ClickHouse, we build some tools to do this data construction outside ClickHouse. So it can reduce the resource contention in the same cluster. And so for the heavy ingestion tasks. And for the second issues, we introduce the local plus shared tiered storage for different kind of data. And then I will introduce this part in more details. So you can see in this figure, actually we can see the data source actually is from HDFS inside ByteDance. And so one way is we can directly ingest the data into ClickHouse, use the internal ClickHouse resources. And so instead, we can also use Spark jobs to call our tools, and we can do the part construction outside ClickHouse, and then use some tools to import this part directly into ClickHouse. And that is the way we do to solve the first issues. Then for the second issue, we think like this, because most of the business, even they don't want to access the data, they still want to keep this data in the system. But this data will be not frequently accessed. So we can, so this data actually is cold data. So we differentiate the hot data and the cold data. So for the for the cold data, we can. We don't need to use the local storage. Actually, as shown here, we can put it into HDFS. So after do this, like if we want to add some resources for the storage part, if the data is cold enough, then we can use the resource provided by HDFS. But before, actually, if all the data is used local resource in local disk, local load, then because we know the computer resource and the storage resource are changing over time, right? So so actually it needs us to planning ahead for the ratio for the computer resource and the storage resource. Otherwise, there will be some resource waste. So after we do this, then this both parts actually can scale on demand, especially for the cold storage. Yeah, that is the way the way we solve the second issues. But we still ask ourselves is after we did this, is elasticity good enough? And can we or put it in the other way? Can we apply this approach to instead of owning for cold data, can we apply it to hot data as well for normal use case for the daily queries? So that is the way. So that is the task we are working on, and so we started to explore the possibility of the shared storage architecture. And so, yeah, you can see in this figure, actually the ClickHouse, vanilla ClickHouse is a shared routing design, and so we start to do some exploring on the left part. So the idea is simple. We just use this approach, like shared storage plus local cache. So the local cache can still guarantee the performance. So the benefit we do this is we can achieve better elasticity because the computer resource and the storage resource actually can scale independently. And the other benefit, the second benefit is it will be more cloud friendly because of elasticity. So we can increase or even close all the server load when we don't need it. And so it can like if we are running it in cloud, then it will save some money, something like that. And also we can also utilize like the third-party storage like HDFS or even object store like Amazon S3, something like that. But there is also some limitations for this architecture, like it involves new dependency, right? So like the shared storage part. And also the second limitation is it requires some carefully design on the network part inside the, no matter it's an on-premise class or cloud, because you can see after we change to shared storage, then like even each ClickHouse instance need to may can communicate with every data load inside the whole data center. So it has more strict requirement for the network design. So currently for this work is still under development, and once we have some more results, we can share more in maybe next event. And then and we also have another issues for the data related part, and is have some new requirement from the business because the data actually the model is more diverse. So we need to use some dynamic schema, but at the same time the users still expect high performance. So what we do is we provide some propose a new map structure, and provide some specific storage layout for this new format, and so that the queries can run on this new format to achieve good performance. The solution looks like this. So the idea is also quite simple. So we directly extend the JSON to the columns in ClickHouse. So like for example, there are two rows here on the left. The key is A, B, and the second row is key is A and C. So now we have three keys A, B, C. So we will have three columns. So we will notice actually the number of columns is actually the same as the number of total keys. So it has some assumption like the total keys must be controllable. Otherwise, it will involve many small files. So to solve this issue, we also provide another mode, like for applications have many keys, then we can still use this column key and column values, this structure, instead of extend the different keys to separate columns. So that is one we have done. And then based on the first form mode, like the extension for each key, this format, we also do some enhancement. First, as I just mentioned, for this case, if the number of keys becomes more and more, then the the files also will become more and more. So we provide some quota management for the users to control, to don't let users to use too many use too many small files for their requirement for the application. And even we do this quota control, and as the data becomes more and more, it still causes some small file issues, and it causes some high pressure for the iLoad in the OS in single load. So that is we provide another, or do some optimizations, provide another model, the compact model. Then we compact the different columns in a single file and use the offset to point to the different columns. So that is the first issue we have solved. And the next aspect is the high availability related issue. There are 3 sub-issues here. The first one is as the data partition keep increasing, also the path also keep increasing. And so when a node restart, then the recovery time will become longer because it needs to load all parts into memory. And the second one is the extension for the applications, and the zookeeper becomes a bottleneck. For the zookeeper is actually is a dependency component by the replicated merge tree. And the last part is because node becomes more and more, and the failure also becomes more and more. So operations becomes more complicated. So in this part, I will introduce the first part and the failure recovery part. So the restarting actually can be many reasons, like software bug and hardware issue, or OOM, or we just do a normal upgrade. And so the metadata need long time to load. In buy-down scenario, it can take several hours or even more. So what we do is we decide to persistent the metadata. The metadata here is for the data part. But we also catch some hot meta in memory. So as we know, the application, the users actually has some access pattern. So some data is more, there is some data skew on the access pattern. So after running it for a period, so from the user perspective, the response is quite okay, and no obvious performance loss after we do this changes. And also the second benefit is can support more part in single load. And the last one is the restarting will be faster. It will before it will take several hours. Now it only takes less than 5 minutes, several minutes to do the restarting. Actually, for this part, I also noticed in community there is one PR also started on this part, like. Yeah, so maybe we can continue. And yeah, and for the other issues here, like the main reason is what we have done is we optimize on this part and so to reduce the load of the zookeeper part, and we also provide some operation platform to because the operation difficult becomes more and more difficult. So that is we have done. And so for these two issues, because time limitation, I don't go into too much details on this part, and you can refer the details here. And the last part is about performance. Also is quite important. And for when we talk about performance, there are too many reasons can cause performance issues. And what we can do is we can just apply some common approaches to do the optimizations as much possible as we can. And there are two common ways we try to improve the performance. The first is to do some adjustment on the application side. And the second one is we can do some customization for specific applications. And the third way we do is we do some enhancement on the materialized view, like the query rewrite, something like that, to utilize the materialized view more efficiently. And also for this part, more details, you can refer these links I put here. And yeah, and the future works actually is what we are working on. Like this one, first one is I just introduced before, and the second one is we try to do some. We are trying to containerization on ClickHouse, like to make it ClickHouse run on Kubernetes, and this one is also on progress. And the third one is as I mentioned, to increase the resource utilization, so some business can be share some query, some service may share the same cluster to increase the data utilization. But how to guarantee provide the isolations for in the multi-tenant environment is one we plan to do. And also we want to further improve the stability for the service. And the last part is some new requirement from the business, the application side. So before, the scenario is mainly target for analysis, but now more and more users applications want to support some update, like CRUD these operations. Yeah, and this one is one of the to do maybe in the near future by dance. I think that's all. And yeah, the ClickHouse, most of the team member is in Beijing, and so Singapore team is quite new, just started this year. And, yeah, and that's in my personal email. And if you have some question, can discuss offline. It also can simply send me an email. Yeah.
Okay.
Yeah, that's all.
Thank you for your talk. Now is the time for questions. And we have the first question from Huawei Yun that will be online. Yun, I will allow you to talk, and I'm asking you to unmute. If you are here, you will be able to ask your question right now. If not, we will just go to the next questions. And the next question is from Sunset 3000. What is the benefit of map data type over the nested?
Over the nested.
Nested, yeah.
Okay. I think is nest also split the keys to separate columns, right?
Actually not. It is implemented as two arrays. First array with keys and second array with values. So I think that it is completely different.
I think the next for this mode is still for the performance, because if we only need to access like the one key, like look up one key, we only need to access one columns here. So we don't need to like do some further parsing on the like key, and so the key here, like in the bottom figure, the key can be many keys like A and B here, like it's an array. And the value and can be the value of A and the value of B. So it will take some extra, a little bit extra effort to pass the array to get the corresponding like index for the keys. So that is meaning the difference for these two modes.
Okay, so map data type is more like dynamic table structure, dynamic columns.
Yeah, yeah. But it cannot be so dynamic as I mentioned, because we know if there are too many keys, and the number of small file, the number of columns will explosion, right? So that is a limitation. So it has some assumption if the application, the one application use this mode, it has the assumption the total keys actually is relatively fixed, like smaller than some threshold. Yeah.
Mm-hmm. By the way, why don't you just automatically do alter queries to add more columns? It should be not expensive because alter is basically free.
Mm-hmm. Yeah, but that case is user need to care about the schema, right? So here the one benefit is can be transparent for the schema to the end users. I think that is want to do some, so user can benefit on this, so they don't vary the schema for this kind of types for some use some scenarios.
Mm-hmm. So the next question is from me. What is the largest size of your cluster?
Maybe for this we can discuss offline. I feel I'm not sure I can answer this online on this. Yeah, maybe. Yeah.
Okay.
Yeah.
Another question is also from me. So you have very many features that you implemented in your own fork of ClickHouse. But what version of ClickHouse does it based on?
Actually, the native we will merge with upstream for like twice every year, and so because we know the community are keeping the optimization, we have tons of optimization from upstream, right? So I feel the latest version we have merged is 19.5, if I don't remember wrong. And recently we are also doing the merging rebasing on the upstream. The work is already started, and so to update with the latest optimizations from the upstream. Yeah.
Okay. The next question, if you will contribute any of these features to upstream, what will be the first?
I think it's the extra effort is may need to do some code cleaning on the for the internal, to like remove some dependency or make the code more readable or add more comments, something like to improve the data code quality, something like that. And so actually the team has I remember the ClickHouse team leader Chen Xing. I'm not sure whether you are familiar. He should also contribute some, but recently the contribution becomes less because the internal task becomes more and more. So the team members don't have enough time to the contribution to the community. And but in the future, we definitely should do this. And
Okay. Yeah, if you are talking about Chen thing.
yeah.
Yes, I know him. Yeah, and there were some contributions that we have already merged. And the next question is also from me about user-defined functions. What is the mechanism of its implementation?
Which part? The
User-defined aggregate functions, UDAF.
Oh, for this part.
Yeah.
For this part is meaning for the some UDF for the aggregation scenario, like maybe need to group by day, something like that. So
yeah, but it's unclear, is it implemented directly in C++ code in ClickHouse, or you have some system of pluggable functions?
it is still in the C++ and in the ClickHouse code base.
Okay, no magic.
Yeah, no magic.
Yeah. Another question is probably to me from Don. HDFS. So HDFS feature is implemented both in ByteDance and in QuiShow. Do we have any roadmap to integrate it and implement in open source version? And the answer is yes. And we already have a pull request in review stage. And we already have a prototype, and this prototype basically works. And the version of HDFS support in QuiShow, as far as I remember, is based on this prototype. If I am correct or if I'm wrong, Amos Bird can...
It's not... can you hear me?
Yeah.
Okay, so it's not based on the upstream. It's the HDFS implementation in QuiShow is implemented before I enter in QuiShow. And I guess it's long before the prototype appears in the PR requests. So it's a bit different.
And what we should do with this prototype and how to merge these versions together?
So I think that PR, yeah, I've reviewed that PR and I played it a bit about it. So the question is, we'd like to use the S3 or HDFS as a code storage, but in the real world, real world requests in QuiShow, I guess, and in ByteDance, we need to do some replacements of the local disk. So we'd like to have a completely separate storage and computation. I don't think that's how we did for the PR for now.
It should work. Both S3 and HDFS shared storage can be used in two different scenarios. For cold storage with caching of data on local disk, or as the only available volume. So all data will go to HDFS or S3. At least this is what is intended. So we have to experiment more and merge.
Yeah, I think I can I can do some experiments on that PR in near future.
Okay. So more.
Yeah, if Tianqi also are working on this part, maybe we can discuss more maybe later.
And that would be perfect.
Okay.
Learn from you.
the next question for Neo. Did you compare the implementation of shared storage that you have with our implementation of support for shared storage on S3?
You mean compare the performance with HDF and the S3 scenario?
No, I mean that in recent versions, we already have support for shared storage directly in open source version of ClickHouse. And how does it compare with your implementation?
For this part, we haven't do the comparison. We mainly, yeah, we can do this later. And yeah, we are trying to compare with a vanilla ClickHouse and for the same data. Yeah, currently we only do this and haven't tried the shared storage implementation from the community.
Okay. Another question is from my friend. He wants to watch your presentation about HA merge tree, but your presentation is available only in Chinese, and my friend cannot understand Chinese. So is there any chance that this presentation will be available in English?
Yeah, sure. I will ask this requirement inside the team, and then maybe we can translate or add some subtitle in the video, or even if there is still have this event recently, we can also ask my colleague responsible on this part to share in English, and that will be, is this okay?
Yeah, we do these events regularly, so we will be happy to invite your colleague if he can tell more about HA merge tree, because it is really interesting.
Now you can first take a look the slides that HA merge tree, that figure, the basic architecture is in that figure should be in English, but the presentation is in Chinese.
Okay. So, any more questions? Another question is probably to me. Are there any plans to integrate persistent memory technology into ClickHouse? You mean persistent memory like Intel Optane? Actually, we already have some implementation that is, but it is very limited. It is for dictionaries. We can store dictionaries not only in memory, but also on SSDs. And it is optimized for NVMe SSDs and for Intel Optane. But it is like some side functionality in ClickHouse. Is not for main ClickHouse storage. For main ClickHouse storage, I can note that it is mostly optimized for sequential reads, for sequential read performance. So it can work pretty good on HDDs, better on SSDs, but there will be no much difference between SSDs and Optane. We just don't do that many random read operations. So I don't expect that it will give many benefits. So the answer is no, we don't have these plans. And now you can stop sharing your screen, by the way. And now we have the next talk. And the next talk, if is from ClickHouse world-class expert, Denis Zhuravlev, more well known as Danny Crane. If you are a ClickHouse user, if you read ClickHouse groups or ClickHouse issues, there is very high chance that you already know Danny Crane. So welcome, Danny Crane.
Hi, 1 second.
Okay.
Yeah.
The talk will be about everything you should know about Materialized View. It is very comprehensive overview about any possible way how you can use Materialized View, how you can make mistakes, and how to avoid mistakes. So, did you find your presentation?
I'm going to start sharing this 1 second.
Okay.
Sorry for delay.
And I will look for more questions. Okay, it's perfect.
Yeah.
I see your screen. Let's start.
Okay. Hi, I'm Denis Zhuravlev, aka Danny Crane, and Danny Crane is actually literal transliteration from Russian of my name. And I live in Atlantic Canada, and I work at a company named RevJet. We make internet advertisement platforms. And I'm a DBA, I'm not a developer. And I have worked as a DBA for more than 20 years. And now I work mostly as a ClickHouse and vertical DBA. Today, I'll try to shed some light on Materialized View internals. So probably you've heard more than once that Materialized View is an insert trigger, and that is true. The most tricky part is that Materialized View never reads its source table. But how Materialized View works internally? When ClickHouse gets an insert into a table with Materialized View, and for example, on this slide, I show the insert, and this insert has 3 million rows. This insert is processed in a streamable manner, and its data will be separated into 3 blocks because of settings, in particular because of max insert block size, for example. And these blocks will be written into a table and into a source table, main table. And every block can be separated into several parts on disk because a table have a partitioning, and if a block has several partition and key values, then this block will be separated into multiple parts, and several parts will be written on disk. If this table has a Materialized View, then Materialized View will get this block, but not from the parts, not from the disk of the table, but from the insert. So, and this select of which is in materialized view will be processed against this block, and the result of this select will be written into several parts, will be separated into several parts, and will be written into table storage of materialized view. Important part that materialized view never reads the source table except the populate stage, and the source table can have any engine. Engine of this table, source table, actually doesn't matter, and it can be even engine null or engine Kafka. These two engines, they don't store data on the disk, but everything work as with merge tree table, because materialized view select, it never reads the data from table. It reads data from inserted blocks. So insert is happens is the same. It's actually goes into a null table. For example, it's separated several blocks, and it's not written on the disk, but materialized view gets the data from insert, and everything works fine as expected. What is use cases for materialized view? How can we use materialized views? For example, it can be used to pre-aggregate data. In this case, data is usually stored in summing merge tree or aggregating merge tree. And for example, I have a table with data for the last 3 or 4 years, and this table have probably 400 billion rows in a cluster. And I also have several pre-aggregated tables with the same data, and they are filled using materialized views. And data in these small tables is grouped by hour, day, month, and the number of rows, millions instead of billions. So it's probably the most used use case. Also, I use materialized view as a sort of entry point and extract transform tool. So I have a null table, and I have a script which knows how to insert data from several different data sources. It's mostly files, and into this null table. And it's sort of one column data with a single string column, and data is JSONs. This null table has a multiple materialized view around it, and these materialized views perform different data transformation and write results into different destinations. Another use case is you can also duplicate data using materialized view and store all rows of the table in another table, sorted or partitioned by other columns, and if you need it for faster search. Also, I use materialized view to emulate inverted index. It's pretty much the same idea as sorted a duplicated table sorted by another column, but it's slightly another idea. So I have a table, and this main table is wide, and it has like 500 columns. And this table has a high cardinality column, for example, transaction ID. And but this table is sorted by other columns, which it is needed for main reporting. But this transaction ID is very useful sometimes for debugging and for drill down to the data. So sometimes we need to search by this column. So I made an additional narrow table that stores primary key columns from the main table and this transaction ID column, and sorted this table by this transaction ID. So we do lookups by index in that narrow table by transaction ID. And after that, we just jump by primary key into the main table. It's a single query with subqueries. And this additional narrow table is filled by Materialized View. Also, Materialized View is used by Engine Kafka and Engine RabbitMQ. This is probably the only way to store data from these engines. And yeah, it's another use case. How to store, how Materialized View stores its data. Materialized View uses an ordinary table to store its data. We can use two syntaxes to define the storage table: the syntax with engine and the syntax with to. Syntax with engine and the syntax with to. So if you use syntax with engine, then Materialized View creates an implicit table and names this table as dot inner dot Materialized View name. Such inner table has a dot in the beginning of the name, so it can be queried only using backticks or double quotes. This is a restriction for the objects with a dot in the name. Inner table actually is an ordinary table. You can use any commands against it, like describe table, show create table. You can insert data in this table, or you can truncate this table. It's an ordinary table. You can select data directly from this inner table, just the table. But I don't use syntax with engine. I use only two syntax because it's more convenient. So I create a table explicitly. It's the same table as inner. If you do describe, you will see actually the same. After that, I create Materialized View and point my explicit table using two syntax. So what is going on under the hood in these both cases? Materialized View executes select against the inserted block and stores result into inner table. In case of explicit destination table, Materialized View do the same. It's actually do select against inserted block and store the result into destination table. These two syntax is used when this two syntax is used, it doesn't create inner table. The data stored only once, only in destination table. It's mostly the same. It doesn't actually any difference, but in this case, the table is this storage table is named is inner, and in this case, it was created explicitly by myself, and it's named destination or dest, like in this slide. What else is different for implicit inner table and explicit to table? Optimize move to preware doesn't work with Materialized View. When you query Materialized View by name, so if then Materialized View named MV1, and if you do select against this, optimize move to preware doesn't work. This is inconvenient, and it's a small issue, and probably it will be resolved someday. Also, populate does work against implicit table and doesn't work against the Materialized View with explicit table against this materialized view with two syntax. But it's really doesn't matter. I'll explain it later. Drop table in case of implicit table drops inner table as well. Drop table in case of explicit table, and to syntax doesn't remove explicit table, and this is actually very convenient. What is important to know also, you can insert data into materialized view, you can insert data into inner table, you can insert data into destination table. ClickHouse executes an ordinary insert in this case. Materialized view select doesn't participate in this case. Populate, I never use it. It's unusable, slightly unusable for now, because during the populate stage, materialized view misses rows inserted into its source table, because materialized view will be created after the populate finished. It can be fixed, and in ClickHouse code, and probably it will be fixed one day. Another problem that populate runs against all data, and if you have a billion rows in a source table, then most probably the populate will be interrupted by a timeout or by out of memory. And today I'll show how to fill data manually without using populate. I'll show it later. Common mistakes and questions about materialized view. First of all, a storage table where materialized view data is stored knows nothing about materialized view or about selects in materialized view or about the source table. For the storage table, insert by materialized view is just an insert, and it's nothing special. The storage table inner or destination is independent and merges its data according to its own order by partition by rules, and it doesn't involve materialized view on materialized view selects. The most common mistake is the wrong order by in the storage table. In this example, I create a sum and merge tree table and partition it by month and order it by columns A and B. And I use select ABD and group by ABD. Such materialized view will be filled with garbage because column D will be corrupted by sum and merge tree engine. Sum and merge tree engine aggregates all columns not mentioned in order by section by sum or any. So in this case, actually, the column D has a date type, and it will be aggregated by any. Numeric columns in sum and merge tree aggregated by sum, and the other types aggregated by function any. So during populate, you may see something close to the correct result, but later mergers will destroy data or collapse data in D column. And the column rule is that order by section in the storage table of materialized view has to be the same as group by in select section. So order by, group by. And in this case, D column won't be corrupted. Everything will be fine. The second mistake is a double grouping in materialized view selects. Because materialized view select work against the inserted block and not against the source table, the result may differ if rows came in several or in one insert. Again, it can work during populate because populate reads the data from the table, but cannot during inserts later. In this example, I compute some state by hour from count by minute and max state by hour from count by minute. Obviously, some state can work, but max state cannot. If we insert two rows together, by one insert, the count by minute will be 2, and max from this count also will be 2. And in second case, if we insert rows one by one, count by minute will be 1 for both inserts, so max will be also 1. And sum by hour will be correct, and this makes more confusion. But yeah, double grouping doesn't work, and there is no good solution for this case. The next common mistake that materialized view is not related to the source table. It has zero knowledge about the source replacing or collapsing merge tree tables, and it cannot follow the merger. So if you do like optimize table, or it's do it automatically by scheduler against replacing source table, nothing will happen with materialized view. It's simply impossible because materialized view acts as an insert trigger. Materialized view also has zero knowledge about concatenates or deletes or drop or rename the source table. And this is actually good. Materialized view is able to store data for a different period. The source table, for example, has data for the last 6 months, and materialized view can store aggregated data for last 10 years. And I use this design pattern in my projects. The next problem, materialized view uses columns names. You should use aliases in materialized view select to match the column names of the destination table. In this example, you can see that materialized view has a column named CNT, but select count function doesn't have an alias, and this count goes nowhere. And the most ugly thing that is that at the populate stage, ClickHouse uses columns positions, and this materialized view will be filled with correct values during the populate and with zeros in CNT columns during inserts. This is a known issue, and it will be addressed eventually. So a solution is easy. You need to just alias count column as CNT, and this column will be filled with correct result in both cases, in populate and during insert. This behavior appeared recently, and probably in 1916, and because now ClickHouse allows a different column set for materialized view select section and a storage table. Now we can have columns with defaults in materialized view storage, and you can omit these columns in select. And materialized view select now can query more columns when storage have, and it's convenient sometimes for complicated select queries. It can be simplified. So before 1916, if you made such mistake, you you will notice this immediately on the first insert, because ClickHouse will fail with error that Materialized View table storage doesn't have count column, but now you need to be careful because you don't get the errors. Now I'll explain how Materialized View can be used with replicated engines. On this slide, insert creates a part in the source table, and this part is replicated. And how we can replicate data in Materialized View? We should create a Materialized View storage table with a replicated engine with the same shard and replica arguments, and as in the storage table, the same arguments as a storage table, and create the same Materialized View on the replica on the replica server. And the parts which are created in Materialized View because of insert will be replicated the same way as a source table data. And it's a simple replication for Materialized View storage tables. So insert goes to the main table, source table, and parts replicated, and Materialized View also create parts, and these parts will be replicated by storage table to another server, and everything will be consistent. Everything will be okay. People often ask, can I insert on one server and create Materialized View to the for the source table replica on another node? No, it's impossible. Again, Materialized View is an insert trigger, and Materialized View works on node where inserts happen. Replication work with part, and it doesn't involve inserts, so no inserts here. On a replica server, replication sends files, but not a log with insert. The most common schema is to create the same tables and the same Materialized View on all replicas and insert on one or multiple replicas. Parts will be the same on all replicas for both the source table and Materialized View, and everything will be consistent. So for the main table, you can insert data and the parts goes there, and parts created for Materialized View goes there, and vice versa from another replica. The data will be the same for Materialized View on both nodes, and everything will be consistent. Cascades. Starting from ClickHouse version 1916, cascading was improved, probably by Amos Bird. Thank you, him. Yeah, and we can create a Materialized View for another Materialized View. It usually is used if the first Materialized View has some hard computation, so the second Materialized View can use the result from the first Materialized View. There is only one annoying issue. It needs to use a storage table as a source for the second Materialized View. So the first Materialized View reads from table, and the second should read from storage table. So for implicit storage, use inner table. For Materialized View with explicit table, use to destination table in the from section for the next Materialized View. When the first Materialized View insert the data into its storage, it triggers the next Materialized View. And also this probably also a small issue and can be fixed. Probably it will be fixed. And it's worth to mention that before the ClickHouse 1916, it was exactly the opposite. We had to use Materialized View name in the next Materialized View, and we couldn't use storage tables. It brings a lot of confusion during upgrades. But because of this change, Materialized View are now supported for Kafka engine. So if you ingest data from Kafka, and you can use several cascaded Materialized View, and everything will work in current stable ClickHouses. Can we create multiple Materialized View for a table? Yes, we can. I don't recommend to create 50 Materialized View. It's a real case of one user who had problems with insertion performance. And these problems, because if you have 50 Materialized View during insert, it will create at least 51 parts, and it obviously causes a lot of random I/O, and it works badly on HDD. How does an insert work in case of multiple Materialized View? Insert create a block. The block forms a part, this part is written into the source table. Then the block is propagated into the first Materialized View, and this Materialized View create its part. Then the same block is propagated to the second Materialized View, and so on. And Materialized View are processed, views are processed in alphabetical order, so A, B, C. There is a setting, parallel view processing. If this user setting is enabled, equal 1, then the right after an insert into the source table is completed, part is written. Materialized views are processed in parallel by multiple threads. If you enable these settings, it can speed up inserts if you have more than 2 Materialized view. It's a very useful feature, and we use it. Why do we need to know about Materialized View processing order? Because it needed to get consistent data even with insert failures. ClickHouse inserts are not atomic among source table and Materialized View. In this slide, ClickHouse got an insert with 3 million rows. And this insert was separated into 3 blocks. The first block was processed successfully, and the source table and all 3 Materialized View got this first block. While the second block was processed, an error happened during the insertion into the second Materialized View, Materialized View B. And for example, network error calls it as keeper error, and the outcome of this error is inconsistent state of the Materialized Views. The source table got 2 blocks. The first Materialized View A got 2 blocks, and Materialized View B and C got only 1 block. The third block never happened. The client got an exception and even didn't send it. So we got inconsistent data. But ClickHouse has an important feature, insert deduplication. It works only for replicated engines now, but I saw a pull request to make it work against simple, not replicated tables as well. So it will be probably merged eventually. Insert into the replicated table can be repeated safely because the repetition will be deduplicated. It is implemented to be able to retry insert in case of an error or a timeout. The last 100 insert can be repeated, but retried inserts must be completely identical. The same rows in the same order. Because duplication is based on checksum of a block. In this slide, we have a replicated table, and Materialized view storage table is also replicated. Insert happened and created a part for a source table, and the checksum for this block was written into the Cooper. But during insertion into Materialized view, an error happened, and Materialized view didn't create a part. We can do retry and repeat exactly the same insert, but it will be deduplicated by the source table because a checksum for this block already exists in Zookeeper. Replicated Materialized view gets no data in this case because by default Materialized view inherits deduplication from the source table. This behavior is one of the reasons of many questions in GitHub and chats. So because people do retries and they stay with inconsistent data among the replicated table and replicated Materialized view, because the settings is set to 0 by default. Deduplication for Materialized view is inherited from the main table. If we enable this parameter and set it to equal 1, Materialized view will start to check deduplication by itself using its own checksums, and Materialized view will get data on retry. But this setting is disabled by default because very often Materialized view storage tables we use something like summing or aggregating merge tree, and these tables is a narrow tables, and they can form the same block for different inserted data. Imagine we always insert 1000 rows, and this Materialized view we store the number of inserted rows, just number 1000. When for two different row sets inserted into the source table, we insert exactly the same row into Materialized view with a number 1000. We don't want the next insert will be duplicated by Materialized view, so this by default is set to 0. How we can address it? What we can do about it? If you experience such issues with summing or aggregating mesh tree, I recommend to add a column into the source table with a unique identifier and propagate this column into Materialized view, but don't include this column into order by section of Materialized view storage. In this case, you can enable this parameter and insert into Materialized view will not be falsely deduplicated because of this unique identifier. So if you generate some unique identifier and it repeated in retry, you sort of store an insert somewhere and repeat it with the same unique identifier as it was in the first try. So this block will be deduplicated for the main table and will not be duplicated for Materialized view, and you'll get the consistent data. And this unique identifier will be collapsed during the mergers in Materialized view. So it will not take much disk space, and after some time, you can clear this column using TTL or alter table click home command. Joins and Materialized view. I don't recommend using joins in Materialized views because they slow down insert dramatically. ClickHouse uses a hash join algorithm, and it requires to build a hash table in memory for the right table. And this hash table must be built for each block for every insert. It slows down inserts and wastes memory in case of parallel inserts. Instead of joins, I use external dictionaries and dig-get or engine join and join-get. In this case, we have a pre-built hash table in memory, and this hash table is shared for all inserts. If despite my recommendation you decide to put a join into Materialized view, you need to know each table will trigger the Materialized view. So Materialized view searches for the first real table in the from section and triggers on insert into this table only. If you need to trigger Materialized view on insert into both tables, you should create two Materialized view with the same two destination table. So yeah, you can have any number of Materialized view with the same destination, and it's fine. It's working. In the second Materialized view, you need to swap tables and make the other table the first in the from section. In this example, I replaced left join with right join to achieve that and achieve the same result of the select with join query. Another frequent question is how to use Materialized view in cluster with distributed tables. All four options are possible. The most used is the first option. This option from local to local is the most used and the most efficient. Inserted data is processed locally on a node without network involvement, without any network overhead. Other options should be used only if you really need them. For example, the second is useful if you need to shard data in Materialized view by another sharded key. So you have the main source table sharded by one key, and you need to shard you need to shard your Materialized view by another key, and you can use Materialized view with from distributed and with to distributed. The third option is almost the same. You insert data, for example, if you insert data into local table directly, but you need to shard your data in Materialized view by somehow. So you can use this pattern, this option. Fourth option is also possible, but I can't imagine the use case. And in these options, it doesn't matter that the local table is behind the distributed table. It doesn't matter because the local table, distributed table propagates insert into local tables, and the Materialized view will be triggered by inserts into this local table. And local table, local table will trigger insert into Materialized view. Yeah. And by the way, actually, you can use anything in the to section of Materialized view. In this example, I use file engine. So I create a table with file engine. I create a Materialized view and point to section into this table. And during insert, everything works, and queries from this table also works, and you will get data as JSONs in this file engine. Yeah. And you can even create a remote table and insert data into another cluster on, for example, on another region or something in another cluster. So in this example, I create remote SRC log table as a remote and use this table in to section in Materialized view. Can Materialized view be altered? Yes, it's possible. You can change the storage table and then change the Materialized view select section. In case of implicit inner table, you need to stop insertion, then detach Materialized view. You need to stop insertions because if you don't stop, you will miss insert into the main table because Materialized view will stop will stop triggering when you detach Materialized view. So you stop insert, detach Materialized view, alter inner table, for example, add or modify columns, and attach Materialized view back. And in case of explicit table, it's pretty same. You stop insert, alter the destination table, drop the Materialized view and create Materialized view. It's more convenient way because you don't need to do attach Materialized view. It's more transparent. You need to just drop and create Materialized view back. And because of destination table isn't dropped, everything will work as you expected. And here on this slide, I'm showing that how you can do in SQL view. In SQL, I do detach Materialized view table. I do alter, and here is a complicated case. I'm adding a new dimension to a table with sum and merge tree. So in a single SQL command, I add column and I modify order by of this inner table. This modification doesn't change anything on the disk, but it changes how merges on this table behave. And then I attach Materialized view with a new select. So obviously I edit B column here. And in case of explicit syntax, it's the same, but it looks more transparent because you just need to drop and create Materialized view with a new select. The only inconvenience that inserts must be stopped, but there is an experimental feature. This feature allows to change Materialized view on the fly, and you can alter the storage table before or after this alter. And because of Materialized view can have another set of columns, different set of columns from storage tables, it it won't be any errors, because this new column, for example, we added a new column into Materialized View Select, and this column doesn't exist in the storage table. It goes nothing, and right after you edit this new column to the storage table, it will be Materialized View start to fill this column, and everything will be working. And now I'll explain how to fill data, how to fill Materialized View for existing data, how to do populate manually. For example, if you have a huge table of billion rows, and there are several ways. Probably your source table has a column with a timestamp, and we can pick some date in the future. For example, in this case, I pick 1st November, and I create a Materialized View with this date in the section. And when this date arrives, it will be started to write into destination table. So it will be started from tomorrow. And tomorrow, you can fill Materialized View with data for days before this date. Piece by piece, for example, by 1 month or by 1 day, you just do insert into destination table. If you have a summing merge tree or aggregating merge tree, you can insert into destination table directly without group by, without counting sum. Summing merge tree and aggregating merge tree can do aggregating this group by automatically, but in case of aggregating merge tree, you need to use a special state function to fill initial data in the column without aggregating. Another way, you can create Materialized View on the fly, and the first also without stopping insert. It was also on the fly. So you create a Materialized View, and this, for example, for this date, for the current partition for this Materialized View will be incomplete, because when you created Materialized View, partition already, so this date or partition already started in the main table. So then a new partition starts, you can drop the incomplete partition and populate it from the source table. Or you can use alter delete and delete incomplete date and incomplete day and populate this day. The third way, for this way, we need to be able to stop inserts. So we stop insert, create Materialized View, and we fill Materialized View destination table with the today data. After that, we create Materialized View, start insert, and we already have data for today, and it's complete and incorrect data. And when you create Materialized View, it will start to fill data into destination table with today data, and you can insert data before today. And one more way to populate data using alter table freeze. For example, if you don't have a date column, and in the main table, and you need to populate data in Materialized View. You create a destination Materialized View storage table and stop inserts. After that you alter tables source freeze. It creates a backup in shadow directory and create Materialized View, start inserts, and after that you can create a temporary table as a source table. It will have the same structure as a source, the same partitioning, the same columns, everything is the same. And after that, you can, using these commands, you can attach data from the backup to this temporary table and populate your inserts already started. And you can populate destination table from this snapshot. And when you finish the populating, you can drop this temp snapshot table. This temp table, doesn't use disk space because alter table freeze uses hard links. And it's a very cheap and very quick operation because it creates just hard links on the disk. And the last slide is some cookies, useful links. I have these links. Try to play with these examples. You will get to use it, and you will get understanding, and Materialized View will become transparent for you. And I see very useful example here. It actually allows you to convert Materialized View with implicit inner storage to explicit storage with 2. And that's all.
Okay, thank you. By the way, the presentation is really complete. It really covers all the detail about Materialized View. But we still have some questions. And the first question is from YouTube, but it's not a question, it's more like a statement. If I delete records with alt or delete, Materialized View will not be updated. And this is painful.
Yeah, and actually, it's not painful. It's the idea and how it's how Materialized View works. It's actually they see only inserts, and it's really impossible to get consistent data, because if you aggregated data, for example, if you have only one row in Materialized View, because it's aggregate data to one row, you actually don't know which rows, and you delete rows, you don't know how to populate. You can, but it's really hard, and probably we need another Materialized Views which can be populated by scheduler, by some cron.
Okay, so the bottom line is that Materialized View really is a trigger for insert, and nothing more.
Yeah.
The next question is actually not a single question, but multiple questions. First, can one Materialized View select from more than one table?
No, but you can create another Materialized View and select another table. I showed it in my slides.
Yeah, and probably this is another case for select with join or select with subquery. It was already covered by the presentation. So the next question is, can several materialized views insert data into one destination table?
Yeah, and I covered this in my presentation. I showed the example. Yeah. Yeah, but only one thing that it has to be a table which allows you to do parallel inserts. So it has to be merge tree table, for example. Because if you use engine file, for example, it will fail because engine file doesn't allow parallel insert over here. So yeah, be careful, but everything is possible.
Yeah, and another question is probably very simple, very easy to answer. How to know when insert into materialized view is finished?
Yeah, I didn't cover it these parts, but actually then insert into the main table finished, it's materialized view already get all data, and it's already the parts already active, and they are available for select. So then the insert propagate it block into materialized view select. It actually waits for materialized view response that everything is finished.
Yeah. So when your insert into the main table is finished, at this moment, all inserts into materialized view also have finished.
Yeah.
And another question is why materialized view does not update state when you do attach query? Alter table attach.
Doesn't update state, I don't know. Because it's insert trigger, so it's...
Yeah, it works only for inserts, not for attach. It is just a limitation. Maybe we can do something similar to populate to support this scenario. But we have to fix populate first.
Yeah. Yeah, so yeah, maybe, yeah, probably it's possible. Then you detach materialized view, maybe, yeah. No, you will miss inserts here anyway. So I don't know. Maybe you should use live views. Live views is another feature, and it populates data by scheduler. Maybe it's useful for you.
And the next question from Wang Chao, it will be online if Wang will be able to talk. Wang Chao, please, if you hear me, please unmute your microphone and you will be able to ask your question online. Or maybe you just have pushed the button by mistake. Okay, I see. It was by mistake. So any more questions about materialized views? I see no more questions because your talk really covered all the details.
Yeah, I hope.
Okay, so thank you again. And now we have a lightning talk from Winter John. John works in a company named Chin Cloud. And he is going to present the most fresh, the most new, and the most appreciated feature that is named Materialized MySQL database engine. So welcome. Let's start.
Hi, Wait.
Hi.
Hi.
By the way, the talk will be in Chinese, but after the talk, we will translate some details. Okay, let's start.
Okay.我是使用中文，我就说中文了。首先我跟大家今天主要跟大家介绍一下这个20.8开始引入到 ClickHouse 当中的一个新的一个特性，叫 Materialized MySQL Database Engine。然后首先想跟大家介绍一下自己吧。然后就是首先我是那个ClickHouse 的 contributor， 然后这是我最近吧，就是从最近到过去，然后的一些主要的一些贡献。然后呢，如果说我们要在我们先回顾一下，如果说我们要在 ClickHouse 里面使用 MySQL 的数据的话，我们有几种方式。首先，第一种是使用 MySQL 的 Table Engine， 对吧？然后MySQL Table Engine 主要是说在 ClickHouse 当中映射将 MySQL ClickHouse 当中的一张表映射到 MySQL 的一张表上，然后呢，它的数据呢，它的表结构呢是通过实时的从 MySQL 里面拉取出来的，然后并且呢，它的数据也是在你查询的时候实时的从 MySQL 里面去拉取。然后这样的一个问题在于说，它可能就是它是每一次查询都会拉取一些数据，然后呢做了一些有限度的一些位词的一个下推这样的话就是数据永远都是在 MySQL 当中。然后呢，它还有个问题呢，就是说它没办法去就是没办法去就是说它是一个表级别的它只是说一张表对应一张表。如果说我有很多张表的话，它会非常的麻烦我要对每张表去建一次，每张表建一次，每张表去建一次所以说呢，应对它的缺点呢，它就是有一个叫 MySQL Database Engine。MySQL Database Engine 呢，它是映射于说由 ClickHouse 的一个 database 映射到 MySQL 的一个 database， 然后呢，它呢是实时的去获取从 MySQL 里面拉取这个 table list， 就是把 MySQL 里面的所有的表的列表这个属于这个库的所有的表的列表拉取一遍。拉取一遍之后呢，它也实时的拉取的同时，实时的从 MySQL 里面拉取这个表的结构，以及说当你使用到这张表做查询的时候，它也是说在查询的时候实时的从 MySQL 当中拉取数据，然后到 ClickHouse 端，然后再做后续的计算。然后它的问题在于，它的问题其实和刚刚说的一样，就是它仍然说数据仍然在存在 MySQL 里面那我们现在的这个 Materialized MySQL Database Engine 呢，就是解决这个问题的。首先呢，它也是一个库级别的为什么说是库级别呢？因为在 ClickHouse 当中的惯例来讲，就是如果你是针对于表的这个同步，比方说像这个 MySQL它可能是说就是它对 DDL 来讲是不太友好的。如果说我们要做成 table 级别的，就是 Materialized MySQL Table Engine 的话，那么可能它就没办法去很好的和其他的，比方说外部的数据源一样的一个一致性的行为去对外说，我仍然是同步 DDL， 它就和其他的这个数据源的这个外部引擎产生一定的冲突。然后再一个呢 ，Materialized MySQL 呢，它是消费 MySQL bin log， 然后呢通过 bin log 呢把MySQL 的数据拉回来，然后存到了ClickHouse 的 merge tree 里面然后最重要的是它是一个实验特性，它是在20.8当中加入的。然后我们推荐呢你是使用最新的稳定版本因为20.8之后我们后续修复了一些bug， 然后一些问题然后同时呢，就是稳定版本实验版本意味着它不是特别稳定，但是欢迎大家去试用它，并且去不断的去给我们提供一些意见，比方说我们后续如何改进它。然后首先来讲，如果说我们要在 ClickHouse 里面去拉取 MySQL 的数据那我们该怎么做其实实际上就是非常简单了，已经如果有 Materialized MySQL 这个引擎已经非常简单，我们只需要通过一条 SQL我们建立了这个 database， 那么 OK， 那这时候呢，我的 ClickHouse 和 MySQL 就已经建立了链接，然后建立了这个联系。建立联系之后呢，它就会实时的去 包括以前的数据，对吧？包括包括后续的数据，它会实时的同步过来，它和 MySQL 当中是形成一致，对吧？那如果说我们今天来讲一下，我们就是说，通过这条语句之后，它背后到底做了一些什么啊？首先来讲，它面临两个问题啊，就是首先，我们如何去同步它的历史数据，以及如何去同步它的增量数据，对吧？新的数据，然后呢，在 Materialized那个 MySQL 这个引擎里面呢，主要其实将这个两个主要的问题分为了3个步骤去解决，比方说。首先是我们需要先去 check 一下 MySQL 的状态，然后呢，我们去查询一下 MySQL 的历史数据，然后保存到我们的 ClickHouse 的表当中。然后呢，我们还要去建立一个消费机制，实时的去消费它的新数据，然后呢，实时的保存到 ClickHouse 里面去。首先，我们 check MySQL 这个状态，我们是做了些什么？这是一个在 GitHub 上随意的截了一段相关的代码。我们可以看一下，我们主要是通过一条 check query 去验证当前的 MySQL 的状态是否是适合去进行这个拉取数据建立这些去查询一些历史数据，以及去建立一些消费新数据的这种机制。首先我们检查了说它到底有没有开启 binlog 它的 binlog format 是不是 row， 对吧？它的 binlog row image 是不是 for 以及这个是受限于说我们一开始支持的这个认证插件认证的机制，我们是直接基于 MySQL native password 去做的这件事情。所以说我们目前来指，我们添加了一个验证，说你必须是 MySQL native password 的这种 plugin 的认证方式，我们才能够去支持你去实时的消费你的新的数据增量数据。我们可以看到下面这里面说，只要这4个条件任何一个不满足，我们都会抛出一个错误出来。OK，这是一个检查 MySQL 的这个状态。然后我们再看一下说，我们怎么去实时的拉取MySQL 的这个数据，然后到 ClickHouse 里面去的。首先，这个整体逻辑来讲是分为这个几步的。首先，我们是先去创建一些 metadata， 然后这个 metadata 是通过和 MySQL 去做一些链接，然后去做一些操作，然后拉取一些 MySQL 的一些信息。然后呢，我们会去保证一些那个拉取的一些原子性。然后最后呢，我们是去清除和真正拉取。OK， 我们先来看一下这个 metadata 到底是做了什么。首先，整个 metadata 来讲呢，我们实际上是在做一件事情，就是说，我们去拉取这个就是截取一下当前时间内，我们是建立了一个快照级别的点位，然后呢，相当于这个点位之前我们会把它划分为历史数据，然后这个点位之后呢，我们划分为实时数据，就增量数据。我们怎么做的呢？我们首先是通过2个 flash table 给这个整个这个 MySQL 加一把毒锁，加一把毒锁之后，这一瞬间的时候，加一把毒锁之后呢，它这个时候它就没办法执行任何的 DDL， 就是 MySQL D 已经就是hang住，对吧？MySQL D hang住之后呢，然后我们在这个绘画级别里面呢，开启了一个事物，然后呢，通过这个事物呢，获取到了现在 MySQL 的所有的就这个数据库下的所有的表的列表。然后我们把这个 log 再把它释放掉，然后同时呢，我们保证了这个链接一直保持有这个链接，然后这时候呢就做到了一件事情，说我这个链接已经持有了一个绘画，我这个绘画里面呢仍然可以访问到历史数据点位之前的历史数据，然后同时呢这个 MySQL 呢又可以继续运行下去，就可以接收其他请求，其他请求呢就是增量数据，所以同时来讲，就是从这里。可以把这个 MySQL 的数据分为一个历史数据和实时数据历史数据呢，我们可以通过这个 collection 去实时的把它给查询出来。然后呢，这个增量数据呢，我们可以通过一些消费机制binlog 的拉取，然后把它拉取出来。然后呢，在第2个部分呢，就是说怎么样去保证这个事物。OK， 那我们可以看一下就是这个时候实际上呢，我们就相当于是因为我们刚刚已经建立了一个快照的时间点，我们把它 把这个快照时间点呢，它实际上是有 bin log 的点位的，然后我们把这个 bin log 点位呢记录下来，记录下来之后呢，我们先存储到一个临时文件里面，保证一些事务性，然后呢，再真正的做一些做完这个 dumping 之后，然后我们再给它提交掉啊，这个是很简单的一个文件的一个挂取的一个事务的实现。然后呢，最后呢，就是说我们就要把这个数据真正的从 MySQL 里面，就是包括它的历史数据从 MySQL 搬迁到 ClickHouse 当中。这里主要是实际上就是说，首先把所有的表全部清除掉，在 ClickHouse 里面这个库下面的表全部都清除掉，因为我们保证 Meetup 然后呢，我们就是说去把这个，首先我们通过说拉取这个 MySQL 的这个表的结构，这个 query， 然后呢把它在 ClickHouse 里面去执行一下创建一次然后呢之后呢就是说从 MySQL 里面直接 select， 你看可以发现就是一个 select 星，然后查询出来。就简单的一个 select 星查询出来，查询出来之后呢，把这个 import 和 output 把这两个数据接起来之后，然后它就可以导入到了ClickHouse 里面去但这里面值得注意的是这里，就这个 create table， 因为我们知道 MySQL 里面它是有事务支持的然后呢，它要实现insert update delete 对吧？然后各种各样的这种需求，那么我们在 ClickHouse 里面它的删除和更新是十分重的一些操作。那我们如何实现一种轻量级的这种更新和删除的机制，实际上对于 ClickHouse 去消费 MySQL 的数据是至关重要的。所以呢，我们这里简单做了一下这个一些变通吧，一些需求的一些表结构的改写。表结改写的话，实际上首先来讲是我们首先把这个整个 MySQL 的所有的列全部保存下来。然后的同时呢，我们增加2个列，一个叫 Singer， 一个叫 Watson， 对吧？一个是 int 8的，一个是 uint 64的。然后呢，同时呢，我们在在 ClickHouse 里面呢，把这个表引擎呢实现了 replacement merge tree，replacement merge tree。然后呢，实际上这个用意是什么呢？用意是 Singer 去来保存它当前数据的状态，它到底是存在或不存在。version 呢代表的是说数据的版本当我使用这个 replication merge tree， 然后并且呢把这个选择了一个这个排序的一个就是组件策略，组件策略是通过 primary key 去生成出来的。primary key 的话，如相同的组件，它合并到一起，选择 version 比较大的一个数据之后，我再去看它的 singer 到底是为1还是为负1。如果为1的话，那代表这条数据是存在的；如果是为负1的话，那么就把它剔除出去。所以说整个这种方式来讲，就相当于把 update 和 delete 变成了 insert， 在 ClickHouse 里变成 insert， 因为 ClickHouse 的 insert 是十分高效的 ，update delete 呢这种在 ClickHouse 里面是属于 DDL 级别的，这种是非常低效的。所以说我们通过一个简单的一个变化，就相当于一些改写，简单的一些改写，把这个整个这个操作给它就流通起来。然后呢，我们简单看一下，其实通过 SQL 来说，它是一个非常简单的。我们可以看一下，这是我们在MySQL 里面的一个建表的语句首先它有一个 primary key， 对吧？有个主件，有个 values 这个数据真正存储，它是 ng 是 InnoDB 的。OK，当我的这个 Materialized MySQL 这个引擎碰到了这条建表语句之后，它会做什么操作呢？它实际上就是把这条语句变成这样子建了一张表，然后呢 primary key values 同时保留 value 同时保留，对吧？然后同时加一个 singer 和 version 的一个字段它们默认值都是1，因为你在select insert into select 的时候，相当于把 MySQL 的所有数据select 出来，然后 insert 到 ClickHouse 里面，它的默认版本都是1，从第一个版本开始然后它们的这个 version 列是 version 就是这个1，对吧？默认是1。然后呢 partition 按什么呢 ？partition 是按 primary key， 就是主件。主件你看发现它是一个 int div， 它是处理了一个常量，这个常量是通过你的类型计算。说它是一个 int， 它是 int 32我们假设来讲一个比较好的一个分区策略来讲，它的分区的数量应该是在1000以内。那么假设来讲，它分区最大容忍它为1000，那么 OK，当这个primary key 为 int 32的最大值的时候，除以这个常量值，那么刚好是1000。以这个为作为分区，然后 outby 呢，就是又把这个 primary key 又重新给它排序，就是因为 这里是丢失了它的这个，就是丢失了一定的精度，然后在这里时候它又会做排序，按照这个排序键呢去划分这个合并这个 version 啊，合并真正的数据。OK， 那这时候其实整个这个整个的历史数据的查询就已经完毕了，就相当于我们把 MySQL 的所有数据加上 version 加上singer 这个列，然后呢，它们一开始默认都是1，然后存到了 ClickHouse 里。然后后面呢，我们就是说怎么将新的数据给搬迁到 ClickHouse 里面就可以了，对吧？搬迁的过程其实也非常简单。首先来讲，我们向 MySQL 发送一个 binlog dump， 然后这个是属于 GTID 的模式的这种 binlog dump 的一个指令。然后呢，发送完之后呢，实际上呢，我们就可以通过这个，我们去请求拉取 MySQL， 我们一旦发起了 dump 之后呢，它就像然后我们就可以去 MySQL 里面实时的拉取 MySQL 的 binlog， MySQL binlog 的时候拉取回来之后，相当于就是 MySQL 的就是增删改还有一部分查询，比方 DDL 的查询，它都会以 binlog 的方式记录在 MySQL 里面，然后我们拉取回来之后，然后我们识别它，然后做一些处理就可以了。其实整个过程来讲，就是分为2个部分吧，2个部分，然后一个是就是说，我是怎么去处理的这个，就是怎么去拉取的，怎么去解析和 MySQL 去做协议之间的交互，然后再一个就是我去处理这个拉取回来的 event，简单来讲，这就是实际上我是和 MySQL 去做沟通去做协议的一些桥接，然后发送 MySQL binlog dump， 然后读取这个 binlog event 这个其实就暂且不讲，因为这个和 MySQL 文档里面大家可以去看一下，比较简单然后呢，我们就是看一下，就是说如果我们把这个 binlog 拉取回来之后，我们怎么处理的首先来讲，我们只会处理 MySQL 的是几种 binlog， 一种是 MySQL 的这个write， 然后 delete， 然后 update 这3种binlog event， 再加上一种 query binlog event。首先前面3种代表的是你的增删改，对吧？后面一种代表的是你的 DDL。然后我们分别来看一下我们假如说来讲，我们在 MySQL 里面执行一个 insert，MySQL 这时候会发送给我们一条 binlog 叫做 write rows event write 的event log。这是我们做什么呢？这是我们做其实非常简单就相当于，我的鼠标不太好使就相当于实际上就是大家可以看一下这个 on write or delete data 的时候，实际上相当于说我们实时的从 MySQL 拉取数据之后，然后给它标上一个singer 为1的把这个 singer 列编成为1，然后呢把这个 version 列呢就是 metadata 的 version data version 加就相当于当前的版本再加一个版本上去，然后直接给它写进去就行了我们不需要做太多的处理，我们直接写进去就行了。比较简单。同理，其实delete event 也是一样的处理。其实，但是它的唯一的区别在于说，我们delete 标识的是-1，然后我们的写入标识的是1。然后 update 来讲，它就是稍微比较复杂一点它但也没有复杂到太多。update 首先来讲，我们是需要去识别说你这一行是否是修改了组件。如果是修改组件的话，那我们应该转换成同等语义的话，就相当于把这行删除掉，然后再给它新增一行如果你修改的不是组件的话，那么我就直接把 version 加就好了因为 version 加之后它自然就是一个新的数据，之后它会放到了数据的顶层上去，然后它会被逐渐的合并上去，对吧所以说这里的话就相当于稍微有点复杂的逻辑，就是说我们要判断它到底是不是修改了你的组件如果是修改组件的话，那这个时候呢，我们新增2行数据一行的 singer 为-1，一行的 singer 为1，这时候-1的就把1的给删除掉了，然后呢1的之后呢就把就可以顶上来了相当于是一个删除再新增的一个操作如果说你不是修改的组件的话，那么我们直接添加一条新的，然后并且以新的 version 给它放上去就可以了，对吧然后呢，最后呢，然后呢，就是还有一个就是这个 query event。query event 的话，我们只是简单处理了一下这个drop rename， 还有这个 create 和这个 alt这4种query 几乎已经可以覆盖到一些基本的一些操作吧。然后这个没什么太大可说的，就是 MySQL 里面怎么操作，映射到同等的 ClickHouse 的一个 circle 里去就好了。 然后这时候呢，我处理完这个 binlog，出来 binlog 之后，它是写到了 buffer 里面我们可以看一下，之前也是写到了一个 buffer 里面去我们写到了一个 buffers 写到了 buffers， 就是每一个表它有个 buffer， 然后写到了 buffer 里面去，写到 buffer 里面去呢，写到 buffer 里面去呢，然后我们在一定的时间范围内满足一定的阈值，比方说多长时间，然后多少大小每个表最大表的大小，然后怎么样的时候，我们给它刷下去。刷下去的同时呢，因为我们要保证密等性，因为可能比方说我们在消费这一批 binlog 的时候，我们还没有下刷，或者是下刷一半了，然后我们突然死掉了，就是ClickHouse 突然 crash 掉了。crash 掉之后呢，我们再重启起来之后，那么我们要保证和 MySQL 的数据的最终一致，我们该怎么办？我们应该保证一个密等性那这个时候呢，我们要从这个 version 的机制方面去考虑。我在每一次的这个批量的下刷的过程当中，首先我是先去记录我当前的就是我先下刷成功之后，然后我才去提交我当前的 version 版本就简单通过这个 metadata 的 translation 我们刚刚也看到那行代码，就相当于先去记录一个临时文件，然后再去提交，提交完之后再把临时文件 rename 过去简单的一个这种的低可靠的，不是特别可靠的这种事物的这种实现然后呢，就再一个就是说，目前来讲一些常见的问题我这是简单罗列2条，我这个遇到最多的就是 MySQL 5.6我们目前不支持，然后呢binlog 的 checksum 呢为这个没有 checksum 的，我们现在也是不支持的。如果说你在这么用的情况下，它会去报一些，比方说MySQL 的协议上的一些解析的问题，因为它最后没有传给我们这个 checksum， 然后我们就没办法解析这个协议这个是目前我遇到最多的2个问题吧。好，其他 thanks。
Okay, thank you. The first question is from me. Is this feature used in production in Chin Cloud?
No. 这个郑博士在吗？
我在，你说。
对。那个我们目前来讲，我们没有应用到我们的产品里面，因为我们这个属于一个实验阶段，然后我们要我们也是在做一些这个就是问题的一些探索发现，就是相当于我们也是定时的要去跑一些比方说一些 benchmark 然后就是一些 test， 比方说 TPCC 乱七八糟这种东西去发现一些问题，然后当然还是有一些问题没有发现。就是也有一些问题也不是说通过这种能够发现出来的。
So the feature is still in experiment stage, and they are still doing some tests about it, like using the TPCC benchmark. So it will still be benchmarked for a while, I guess.
So, but when you expect it to become production ready?
你有排期计划吗？什么时候能够上生产？
上生产，这个目前来讲就是主要的几个，就目前来讲已知的几个问题吧，然后解决了之后，是可以尝试的，上一下生产，主要的问题在于说，目前的一个那个就是叫什么？叫那个就是目前的有一些特定情况下，就是不是特别好复现的，就是说在一些特定情况下它的这个就是数据和 MySQL 当中没办法形成一致，然后我们再排查这个问题。如果把这个问题排查过了之后，我们决定可能说去尝试上一下生产。
So there is one major problem about a very unproducible problem about data consistency. So they are trying to fix this problem, and after that problem gets fixed, they will try to push to production.
Okay. We have the next question from YouTube. Does Materialized MySQL insert data in batches?
它是批量写入的吗？
Yes， 它肯定是批量显著的。 它首先会在ClickHouse 里面去做一个 buffer，一个批量的一个 buffer， 然后当形成了一定的大小之后，它再批量的刷到 ClickHouse 里面去。
So I guess the answer is yes, and every MySQL table will get a dedicated buffer.
Okay. By the way, what is the size of this buffer in memory?
这个 buffer 多大呀？一张表？
这个 buffer 是通过这个 database 的 settings 去调节的。默认来讲，好像是我记得我看一下啊，默认来讲应该是10兆。
It's 10 megabytes default.
Good. Now we have 3 more questions from Q&A in Zoom from EDZ. I cannot read these questions. Amos Bird, can you help with it?
EDZ. Okay, I see. So he has asked 2 questions.
3 questions.
3 questions. Okay. Yes. So the first one is that
好，我看到。
So yeah. 我先跟作者说一下这个问题的题目吧。
好。
So the first question is that the insert works fine, but MySQL updates says that it's a bug. And the second question is that using the version and sign to implement update and delete, does that means that ClickHouse will use replacement merge tree to do offline merge instead of real time? And the third question is, how can we find the version when we do the update? How can we find the exact row that matches the versions when we do update? And then we do the and help us to do the version bump. Do we need to store the intermediate results? Okay.
首先来讲 MySQL 的 binlog 来讲，如果说我们限定了 MySQL binlog 是row image 是 for， 如果是 for 的情况下的话，你每进行默认的话也应该也是 for 的啊。你在每一次 update 的时候，它会传递2行数据，一行就是你之前的数据，一行就是你现在的数据，这是由 MySQL 的 binlog 的机制决定的。
那它为什么提示是个 bug 呢？
哪里提示 bug？
他的第一个问题说，他说查询 MySQL update 提示是一个 bug， 查询 ClickHouse 表的时候提示是一个 bug， 你看到这个问题了吗？
第一个问题是吧？
对
这个实际上这个实际上可能不是因为 MySQL update 造成的，因为我们目前来讲是 MySQL 的同步线程遇到错误之后，它就会把这个异常抛给你的所有的 select， 以便你尽快的发现问题，因为这是一个实验特性，我们期望于用户能及时的发现问题。对。
Okay. So the first question is answered that the feature is still experimental, so we will see it's a bug several times. Perhaps we will get production ready and this will be fixed.
Okay. So now we have another question from Fan Tian. Is binlog dump and single-threaded? And have you tested the performance?
我们这个有测试过，它大概它的性能在单线程里面的话，目前来讲 MySQL 是瓶颈。如果是一个 MySQL 的话，大概3到4万每秒的 event 数量是不是特别大的问题？然后没有测出真正的上限啊，因为 MySQL 目前来讲是瓶颈。
Okay, so the bottleneck is currently at the MySQL side, MySQL side. And the current measurement is about 30 to 40,000 per request per second.
30
or 40,000 per, yeah.
Okay. Not so many, but probably enough for MySQL. So probably ClickHouse is not the bottleneck. Yeah. The next question is, how can you guarantee data consistency in ClickHouse without transaction support? What will happen if exception will be thrown during data consumption?
如果 ClickHouse 没有事务支持的话，你是怎么保证 ClickHouse 和 MySQL 之间的一致性的？如果在操作的过程中 ClickHouse 抛了一个异常，会什么情况？
首先 ClickHouse 抛出一个异常之后，它目前来讲，它有可能写入了一部分数据，有可能没有写入一部分数据。那么但是呢，它的 version 还是就是它的 version 可能是新增了，但是呢，这个新增的这个 version 没有被持久化到我的 metadata 文件里面去。当我下次再重启 ClickHouse 之后呢，我这个 version 还会按照之前的 version 去处理，然后保证你下次消费的 version 和上次消费的 version 是一致的。那么我这时候呢，相当于是我就会覆盖掉之前就是错误的就 class 错误写入的部分。
So the answer is that basically we have a primitive implementation of transaction based on the version template file, and based on that file, we can redo some synchronizations after exception happens, and we restart the ClickHouse, and we will have the data overwritten by the new bin log. And because that the flow is idempotent, so I guess it is how it works to handle the exception.
Okay. And the next question from Sandy Lee. Will Materialized MySQL support sharing the data between multiple ClickHouse nodes, and how?
首先来讲，目前来讲，你的消费的线程必须要在一个节点上，因为如果你在消费在两个节点上同时启动这个 Materializer 这个 MySQL 这个库的话，那么它数据会被消费到2份数据会显示重复。至于说你的数据分布，数据是可以分布的，因为 Materializer 的话，你是可以去对 Materializer 里面的任何的一张表去建这个物化视图通过物化视图的话，你可以把它分发到 distribute 表里面去。然后通过 distribute 表的话，分布到多个节点上去一个 class 的多个节点上去。
So we cannot have multiple materialized MySQL engine to consume the single database. That will lead to duplicated records. But we can somehow build a materialized view and use that materialized view to push data to a distributed table to use that to distribute data to the cluster.
Yeah, looks very interesting. Looks very interesting and easy to mix up. The next question is probably, it is not clear for me, but the question is, what is the benefit of using MySQL engine instead of HDFS engine?
使用 MySQL engine 的这个优势是什么？是吧？
对。
所以MySQL engine 还是 MySQL Metadata？
应该是他的问题应该问的是你的这 talk 的这个吧，我理解，或者你两个都可以说一下。
好，相对于来讲，相对于 Materializer MySQL 这个引擎对比 HDFS 的话 ，HDFS 相当于是你每次查询它都会去这个真的 HDFS 里面去拉取一遍数据。Metadata MySQL 的话，相当于是说，那边 MySQL 在写入的同时，就把数据给拉取回来，并且在本地存储起来。我觉得他们之间的优势在于说，它的查询可能更加平缓。就比方说，它不会说因为一个查询突然造成大量的数据的拉取，然后并且去大量数据的拉取，然后去处理。再一个就是说，因为你已经存在了ClickHouse 的本地，那么你可以充分发挥目前 ClickHouse 目前处理本地数据的优势这个是他们的区别。
So there are basically two main advantages of Materialized MySQL engine. The first one is that we have the data prepared in the ClickHouse side, so we don't need to request the data multiple times. And the second one is that ClickHouse can process its own data more efficiently compared to the external table.
Yeah, and basically you should use MySQL engine if you already have MySQL, and HDFS engine if you already have Hadoop cluster. So usually it's not a question what to use. You should use what is the most appropriate for you. And the next question from Zhang Xiao, what is better, to use final to get final data from replace and merge tree, or to use group by with argmax functions?
你看到这个问题了啊？
我看到这个问题了。首先这个问题我没有测啊，所以我没有办法给出一个特别精确的一个数据啊。但是目前以我就是我了解的情况下 ，Final 目前来讲，因为目前采用了这个新的这个查询的一个结构且查询的构架，它的 Final 目前已经能够并行化去查询，并且我们用 Final 这个的原因在于说 Final 它的实现比较简单啊，我们优先来考虑一些实现比较简单 MVP 最小的一个实现产品。对。如果这个具体的详细的这个性能对比数据，我想可以问一下 Alex。对。
So based on the tests he did, it seems that the final operation has catch up this performance compared to the group by argmax for the recent processors feature, and it's more simple to implement. So he chose this to implement Materialized MySQL.
Yeah, final was significantly improved in performance in recent versions, probably a few months ago. Also, we have a follow-up for the question from Sandy Lee. What about data sharding in consumer by the hash of primary key?
对的，其实实际上就是相当于说，你如果是要做sharding的话，那么你在 distribute 这张表里面分布的时候，那么你就必须以这个主件去做分布，然后同时呢，那么你在每一个节点里面呢，你就必须去创建 replication merge tree， 而不能创建 merge tree。如果创建 merge tree 的话，那么它的数据将不会被合并，因为这时候它会同时就是它会去向你去下传你的 version 和 data， 就 version 和 single 这两个字段。
So I think the answer is that it's doable, but we need to create replacing merge tree instead of merge tree to back up those distributed table, and we will pass to them both the sign column and the version column to allow those local tables to do their merges locally.
Okay. And the next question, maybe I don't understand this question, but I hope to understand. So, what happens with historical data when you create Materialized MySQL?
You can use log engine together with the buffer.
It's from Dong. The last question, maybe I don't understand it.
I don't understand it either.
It's about historical data and some relation between binlog and historical data. But if I understand correctly, historical data will be loaded separately, not from binlog, but from tables directly.
他的问题可能是问怎么样分别处理历史数据和增量数据，但是我没有太看明白。
我也没有太看明白。如果是问的是你说这个问题的话，对于历史数据来讲，我们使用的是 select， 就相当于是一个把整个 MySQL 的表通过 select 查询出来，然后 insert 到ClickHouse 一张表的指定表里面去，然后 将这个库的所有表循环这个操作。然后对于增量数据，我们才会去拉取 binlog 数据。对。
So we somehow do insert select for the historical data, and then we will consume the binlog for the new data.
Okay. So that's all questions about Materialized MySQL. Thank you again for your presentation. And the next talk is from me about the most fresh ClickHouse features. I will share my screen with my presentation. Now you can see my presentation, and it is named Outstandingly Fresh ClickHouse Features. It's about what do we have for autumn this year, what we have implemented in September, in October. But first, a quick recap of what we have added in spring and summer this year. You can see plenty of new features. Some of them are my favorite. For example, now we have implementation of Postgres wire protocol. You know that we already have support for MySQL protocol, so you can connect to ClickHouse with MySQL client. Now it is also available for Postgres client. And there are many features. I don't have time to present you all of this. So just look at this slide and select something that is the most interesting for you. Take a note and ask me about this feature after my presentation. Because right now, I will tell you only about features from autumn this year, September, October. And let's start. First, about new data formats in merge tree. You know that merge tree is the most powerful table engine in ClickHouse. I include replicated merge tree in the family of merge tree engines. And merge tree is storing data in data parts. And recently, there was only one format of data parts available. But right now, we have 3 data parts formats. So, in addition to the classic format, we also have compact format. It is not new. It is available since version 20.3, more than half a year ago. And now we also have experimental support for in-memory data parts. I will explain what it is a bit later. Also, we have implemented support for write-ahead log in case if you use in-memory data parts. And we have implemented multiple settings for data durability. Let me explain it in more detail. So now we have 3 different formats for data parts. First is wide format. It stores every column in a separate file. The second is compact data format. It stores all columns in a single file. Third is in-memory data format. How data will be stored and how the format of data will be selected is controlled by several settings. These settings control the threshold when another data format will be used. First pair of settings control the threshold to use wide data format. If the size of data part in rows or bytes is larger, then wide format will be used. The second pair of settings is controlling the threshold for compact data part. These settings should be set to values lower than bytes for compact part, then compact part will be used. If the size is less, then memory format will be used. And if size is more than min rows for wide part, then wide format will be used. You can imagine it as the following. Wide data format is used for the biggest data parts, then compact data format for smaller data parts, and in-memory data format for the most small data parts. So first about wide data parts. This is the classic format that we already had in ClickHouse. This is how merge tree used to work for all these years, all past years. Every column and every index is stored in its own file. And it is the best way to store data if we want to optimize data reads, especially reads from slow devices like hard disk drives. And also the benefit is that adding a column or removing a column is practically zero cost. You just remove the file, and if you need to add a column, you do just nothing. Nothing is created. Column will be created only in new data parts. What is the difference of compact data format? All columns is stored in a single file, but data is still in column-oriented format. It is just looks like a stripes. The first data for the first column, then data for the second column, then data for another column. Then it was the first chunk, then it will be the second chunk, and again, data for the first column, data for the second column, and so on. This format is the main benefit is that it is more optimal for data insertion. When you insert data in small batches, that was not recommended for previous versions. If wide data part is created, there will be multiple small files created. And it is much more efficient to create just a single file. Actually, it's not a single file, it's a few files. One file with data, another file with offsets, and another file with metadata. But this format is less optimal for data reading. So when you select, more disk 6 will be performed to read this data. So it is not recommended to keep all your data in compact data parts. It is recommended for small data parts, and you can easily control it with the settings. Just specify min bytes for wide part equals to 10 megabytes, and it will work perfectly. It is available since version 20.3, but it was not enabled by default. This feature was experimental for a long time, but now it is graduated. And since version 20.10, it is enabled by default for data parts smaller than 10 megabytes. But that's not enough. Now we also have in-memory data parts that appear to be even more optimal. Data is not stored on disk at all. It is only remains in memory. Plus, you can enable write-ahead log for durability. So if ClickHouse server was killed, you did not get data loss. Data will be in write-ahead log. But write-ahead log is optional. You can disable it if you want even more performance in the price of durability. So theoretically, in-memory data parts are even better for insertion, but only if you did not enable write-ahead log. If you enable write-ahead log, the performance is actually almost the same as for compact parts. In-memory data parts should be even better for select performance. But you should note that data in memory is stored uncompressed. And you cannot keep all your data in memory if the amount of data is even moderate. So again, you have to enable in-memory data parts only for small parts. And you should note that all data is replicated as usual. When you do insert, it does not matter if it will go to in-memory data parts, compact byte data parts. Metadata will be written to the keeper. You will still get the latency of replication. And please remember that as of now it is still experimental feature. In contrast to but I invite you to experiment. It is very interesting and probably you will get some fun. So what about durability? What is it all about? If you don't want to lose your data, you have to use replication. You have to replicate your data in different regions, in different data centers. One data center in Beijing, another in Shanghai, it will be perfect. But what if all your data is on a single server, so you don't have replication? What if you use replication, but all your data is replicated within just a single region? What will happen if you will experience power outage in this region? For example, there will be no light, no power for just a second in one city. Maybe we need to simply call fsync, fsync system call to ask operating system to write data on durable media before answering to insert. You may notice that ClickHouse did not implement that, because actually you have to use replication. But if you don't have replication, maybe it's enough to do fsync. Maybe, but actually it's not that simple. It's not that simple because many difficulties arise. Many questions arise. So the question, what will happen, how the storage media will respond to fsync? Does it propagate fsync through the controller of the media? Does it propagate through write buffer in the storage media? What if you use RAID controllers? What will be difference in behavior when you use software RAID or hardware RAID? If you use hardware RAID, did you disable write cache, or maybe do you have a battery powered hardware RAID controller? So many questions arise, and actually even file systems and operating systems don't implement everything correctly. But if you really need this, we prepared 1, 2, 3, 4, 5, 6, 7, 8. We prepared 8 settings of what you can do to enable fsync, to just enable fsync. First, minimum number of rows in data part to do fsync after merge. So you can avoid enable fsync on insert, but you can ask to enable it after data parts will be merged. And if large data parts will be merged, larger than that threshold, we will sync the data. We can control it by the number of bytes. We have the same settings, to do fsync after data fetch in replication. We can ask ClickHouse to always do sync after insert. Actually, it's not after insert, it is during insert. So when you get the answer to insert, data will be asked to be synchronized to the storage media. When we write files, we also rename the directory. And metadata in file system for this directory also have to be synchronized. Some file systems don't require that, but some file systems do. So we have another settings to force fsync of directory. And you can enable write ahead log for in-memory data parts. And for write ahead log, we also can control the frequency of fsync, the frequency in the number of bytes and the number of milliseconds. And we can ask to sync for every insert. So it is complicated, but if you really know what to do, you will find what to do. So it's enough about data parts, let's go with something more interesting. We have new functions for query normalization and obfuscation. What is the purpose of these functions? Suppose you have a log of queries in ClickHouse table. One example is system.queryLog table that contains all queries that were started or finished in ClickHouse. And suppose you want to group by these queries, but do aggregation without respect to constant literals. So you want to just normalize query. And it is easy to do. We have a function specifically for this purpose that is named normalized query. Easy. It works in this way. First, quite obvious, it replaces all literals, numbers, string literals to just question mark. Also, when we have a list of literals, for example, something in open parent, and then one number, comma, another number, and another number, all this list is collapsed to question mark and ellipses. It also replaces complex aliases, because aliases may actually contain some rich information that we want to just normalize. And we have another function that returns not a normalized query, but a hash value that we can compare for equality, that we can group by. What about query obfuscation? It is completely different thing, and it is very new. Imagine the following scenario. I have a friend, and this friend have a query. And this query has to be optimized because it does not work as fast as it can. And I'm asking my friend, can you please show me your query? But he works in a big company, and this company have very strict policies. And my friend just cannot show the original query to me because it's a secret. And now we have the solution. He don't have to show me the original query. He can post-process it with ClickHouse format and obfuscate parameter. And how does it look? This is an example of obfuscated query. In obfuscated query, all identifiers are replaced to some very mysterious names. All literals also replaced. Numbers are replaced to different numbers. But if numbers are round, like a million or something like that, these numbers just kept as is. String literals also replaced to another string literals. But the language, the character classes are kept. So if it was Chinese, it will be replaced by another Chinese, but with the Chinese gibberish. And about identifiers, it is actually very funny and very mysterious. Suppose there was some domain area in this company, like clickstream analysis, event analysis. Nothing interesting, actually. After we will do replacement by query obfuscator, the domain area becomes actually very interesting. For example, what is cop car load? Or what is eternity rain risk? Or rain hashtag? Molecular. It is very mysterious. But the structure of overall structure of the query allows me to analyze it. So I can analyze it and I can say that probably you can replace sum of if into just sum function, because the function sum takes uint8 argument, and you can pass 0 or 1, and maybe it will slightly make this query slightly faster. That's all about query obfuscation. Now, another very new feature. It's available in the latest stable release 20.10. Background data recompression. You know that in ClickHouse, you can tune variety compression algorithms for tables or for specific columns. Default compression is LZ4. But you can enable more heavy compression to compress data better. You can enable ZSTD, and you can select different levels of ZSTD. But in previous versions, you can apply it only statically for separate columns, or you can apply it to the table as a whole with some rules. But these rules were not very flexible. Are already familiar with TTL expressions. And you can do plenty of different scenarios with TTL. You can delete data, clear data after some time. You can move data to another disk or another volume. You can aggregate data in TTL. But now you can also recompress data. How does it work? Here is the expression that returns the time, and after this time, data will be recompressed with specified codec. Here, after 1 month, relative to event time column. And after 1 year, it will be recompressed with even more powerful compression to save your disk space, to save your resources, to make ClickHouse even more cost efficient. And to implement better support for this feature, we also have some additions to table definition and to alter query. In table definition, you can specify special compression named default. And this default can be changed according to the recompression rules. So data will be compressed with ZSTD with different level and then by delta codec. No, I'm not correct. First by Delta codec and then by ZSTD compression. Okay. And also now it is possible to remove variety of column properties like comment, codec, TTL, default, materialized, alias with alter query. This alter query is absolutely zero cost. So don't afraid, and if you need it, it will help you. This feature is my favorite, and also probably it is favorite of my friend Amos Bird. He already told a bit about this feature, so I will make just a bit recap. In select query, you can have column list. This column list can be specified by asterisk, by qualified asterisk, but you can also modify column lists with transformers. First, you can exclude just single column or a few columns. If your table has a huge number of columns, thousands, for example, you don't want to repeat all of them and then just remove some of them manually. It's much more convenient to write select star except some columns. Or you can replace some columns with different expressions. In this example, I select all columns from a table, but one column is very secret if it contains Yandex substring. And if it is, I replace it to empty string. Easy and very practical. I can select some columns with regular expression on column names. I can select columns and apply some function to all of them with apply transformer. And column transformers can be chained together. I can select columns, then apply something, then replace something. It is all possible. So it is available in the latest stable version 20.10. What about ClickHouse versions? We have stable versions that were tested in our continuous integration environment, in our testing environments, and we have versions with extended support, long-term support. Versions with long-term support are guaranteed to be supported for 1 year. We guarantee to backport the most important bug fixes. Actually, we don't guarantee that we will backport all bug fixes. But for the most important ones, we guarantee it. We have stable versions, and stable versions are the most preferred because won't get them. So, and we twice a year. If you are using old versions like 20.7 or 19.14, or today someone told me that they use 19.5. I strongly appreciate if you will upgrade. But take care. First, read the change log. Read the list of backward incompatible changes. And always install on staging before upgrading in production. It is the golden rule, and this is very true for any system, does not matter, ClickHouse, MySQL, Postgres. What else do we have for the most fresh features? Now we have integration for RabbitMQ, similar to Kafka, for streaming data ingestion. You know that Kafka is distributed message queue. But what is RabbitMQ? It is also distributed message queue. So if we have support for Kafka, why do not support RabbitMQ? But now we do. We do have this support. What about Kafka? We have support for Kerberos authentication. Probably it is relevant not for the most of you, but someone of you will find this very useful and appreciated. Next is about with section in select query. Now, and thanks Amos Bird, who has implemented this feature, with is compatible with common table expressions in syntax. And you can specify arbitrary subqueries in with clause. It does not support recursive common table expressions, but we don't even pretend. We have plenty of new data formats. Now we allow to run ClickHouse without installation, without packages, just copy ClickHouse binary, run it from terminal, and you will get ClickHouse running. We have plenty of other features, some of them for bug reports, and I strongly appreciate to enable integration of Sentry, so we will be able to receive bug reports directly from your production. But it is not enabled by default. Don't worry. It is enabled only manually. We have some new aggregate functions. We have extended precision for decimal fields. If you want to tell me more about any of these features, just ask me after my presentation. And what will be next? Actually, our roadmap is huge. But unfortunately, we have this roadmap not in Chinese, not even in English. For year 2020, our roadmap is written in Russian language. For year 2021, I hope that this year will be even more great than year 2020. And I promise you that I will write the roadmap in English. But I would like to highlight just a few, just some selection of interesting features that will be implemented quite soon. So, we are going to implement embedded support, native support for backups in ClickHouse. It is scheduled for the first half of year 2021, sorry, year 2021, I hope. Next is about gRPC interface for ClickHouse. So you can easily have full-featured clients in every programming language. In Python, in Go, in Rust, with support for all the features like query progress, query cancellation, insertion with external tables. The next is very interesting, but I cannot tell you the exact schedule because it will be implemented by Amos Bird. It is about projections, and I remember it was mentioned in his talk. Next is almost ready, and I hope it will be completely ready in November this year. Integration with open tracing. It means that if you have ClickHouse in your ecosystem with multiple microservices, you can trace ClickHouse requests with ClickHouse distributed requests inside your system. Next is very interesting. It is very perspective, but some people may start to afraid what we will do, what we are going to do. And we are going to provide an alternative to Zookeeper, to replace Zookeeper with our own crafted distributed coordination system. We hope to implement it with the protocol compatible with Zookeeper. So you will be able to migrate your clusters easily or just continue to use Zookeeper as usual. Probably I have no time to highlight all the remaining features. So I appreciate if you will just note some of them and ask me about them after my talk. I will be happy to tell you more and to answer your questions. And I am ready to answer your questions. I hope you enjoyed my presentation. Let's look what questions do we have. What questions do we have in Zoom, in YouTube? So I will read questions starting from the last. How could we appoint a column to be compressed manually or automatically? How to make it compressed according to the size? You can do both. You can do manually and you can do automatically. You can specify column compression manually with a codec specification in a table. You can ask column to be recompressed with recompression TTL rules that I have explained. And about judging by size. In merge tree, data is inserted by data parts. Data parts are merged together in background and become larger. So if you have some old data, it is usually stored in larger data parts. And it means that if you specify TTL rule to recompress data by the age of data, it is most likely that large data parts will be recompressed. Okay, so I will continue to ask your questions, and I want to remind you that you still have a chance to ask your question online using your microphone, using your voice. If you want to do it, just push the button that looks like this. Raise your hand.
Alex, can you introduce the hedged rate part?
Yeah. Suppose you have very huge cluster with hundreds or thousands of nodes, and you have distributed queries that actually have to go to every shard of this cluster. Distributed query will select one replica on every shard, one replica that is alive. So ClickHouse is a fault-tolerant system. But on huge clusters, it's not enough, because on some shard, all replicas can be alive. But some replicas can become occasionally slower than other replicas. And if we will send our request to any of the replicas, sometimes this request will be processed slower because the replica is unfortunately slower. What is hedged requests? It means that we will send our request to one replica, and if it does not respond quickly, we will additionally send the same request to another replica. So we will have multiple replicas ready to answer the request. And whatever replica will it's well-established technique to reduce tail latencies. We are going to implement hedged requests in the first half of the next year. It will be late spring or early summer.
Okay, thank you.
The next question is from John. When will Atomic Database Engine become production ready? And the answer is yesterday. It is production ready since version 20.10, and the version 20.10 is the latest stable version that is already production ready. It was released less than 1 week ago, so it is very fresh, but it is already stable and well tested. I assume that Atomic Database Engine is already production ready. You should start testing on your testing environment. So let me explain what is the schedule of our meetup. Right now, I will continue to answer the questions about features from my presentation. And after that, we will continue to have unlimited, literally unlimited questions and answers section. I know that it is almost 10 p.m. in China Standard Time. So how long will you stay? It depends on you. Maybe you will stay till midnight. It's up to you. And I will continue. So what is an alternative to Zookeeper? Will it be a new component outside of ClickHouse or some module inside? We will do implementation in 2 steps. First step is to provide separate server that will act as drop-in replacement to Zookeeper. But it is only the first step. In the second step, we want to integrate coordination subsystem directly into ClickHouse to simplify your infrastructure. So you will not have to have separate instances for coordination. But it is the second step, and the second step is more distant. I hope I answered this question. The next question is from John. Does ClickHouse support group by positional arguments like group by 1, 2, 3? No, it does not. And it is very easy task to implement. I am 100% confident that if Amos Bird will want to implement this task, he will do it in just half an hour. If John wants to implement this task, the same. Half an hour and it will be ready. And probably Denis Zhuravlev wants to mention that it's not standard SQL.
And it's a very doubtful feature because actually it will break backward compatibility, because now you can group by expression and you can write something 1 plus 1, or you can group by 1, and it actually has sense. So for example, if you use some system that generates queries and it's using like group 1, and it's not a column for now. So if you implement group by numbers and order by numbers, it will break something for users. But probably you can implement it by some setting to enable or disable.
Yes, this is a classical solution. Just add one more setting. The only downside is that we will have too many settings. Actually, I don't like settings. I tell you by the secret, but I want that everything should work fine by default. And about settings, most of people will not change any setting. So the next question, does ClickHouse support user-defined functions, or maybe it is implemented right now? Actually, no. The answer is ClickHouse does not have this support, and we are not implementing it right now, but we have user-defined functions in our roadmap. What is the difficulty? We have some design discussions inside our team, and we have found that there are 6 different ways to implement user-defined functions. Different ways have different compromises in performance, in ease of use, and in reliability. So probably we will implement not even a single way to provide user-defined functions, but a multiple ways to do it. And we will check what will be the most appropriate.
Maybe it should be 2 different ways simultaneously. For example, if you need to process data like you need to process a result, and in some SQL language you need to execute queries. It's one language for user-defined functions, and it will be obviously slow because it will work row by row. And maybe it's you need a second type of user-defined functions for a fast using in blocks in selects for functions. One language for procedures and one language for functions.
Yeah, there are completely different scenarios. For example, one scenario is for functions that are...
you need to write own aggregating functions with doing something strange, and there is no ready aggregating functions, for example. And this function should be very fast because it should work for a column, not for a row. Yeah.
Mm-hmm.
Sorry for interruption. Yeah.
Another question. Yeah, I'm going to tell that there are different scenarios, and different ways of implementation are applicable for different scenarios. So probably it's legitimate to have more than one implementation. The next question: what do you think about CH proxy? Do you suggest to use it? Or maybe you are going to integrate some of the features directly into ClickHouse. About CH proxy. Actually, I did not use it, and it is not used in my company. But I know that it's a good product that is used in many different companies. Maybe someone of panelists will help me to tell their experiences with CH proxy. Dennis, do you have any experience?
No, I don't have experience. We have a similar in-house solution, so we don't use it.
Okay, but what I know that CH proxy is a product that allows you to apply rate limiting, load, additional load balancing, and the most impressions that I know is quite good.
Yes, probably it has some feature like rate limiting for a cluster. So if you're a user and you have a quota, this quota will be applied to a cluster. So if ClickHouse implements some quoting for distributed queries, it will cover this use case.
Okay. And about integration of CH proxy features, do we have plans? Probably not. If we will do some integrations of some features, we will approach it gradually. Okay. And another question, it is in Chinese. I can read it in two different ways. One way to read Chinese, three different ways. One way for me to read Chinese is actually to learn Chinese. But I don't have time to learn Chinese during this talk. The second way is copy-paste to Google Translate. And the third way is to ask my friend. I choose the third way, ask my friend.
Okay, I'll do the translation. So the
Yeah.
question is that about a problem he faced in the production. So he has two tables, one order line, so one order table that is fat, that is very large, and an item table. So they want to avoid the join, so they build a one fat table, but they have to update the item table every day in the rate of hundreds of thousands per day. That makes the updates of the fact table very expensive. But without the fact table, doing the join between the item table and the order table is somehow not fast enough and spend very much memory. So how can we tackle this problem?
So it depends on the size of item table. If the size is not enormously large, I suggest to use dictionaries or join table engine and join get function.
I want to add. Can I?
Okay.
Yeah, so it can be even large. And for example, there is a direct layout for external dictionaries, and there is a SSD layout for dictionaries. So, for example, you have a Redis database, and you can actually query using direct layout. You can query you can make key-values queries to Redis directly, and you can execute this substitution for a join using Redis, yeah, or using other key-value storage, which can reply very fast, response very fast, yeah.
But I have to add that if you use a direct layout, you will get the performance of about just a few 100,000 of records per second. If you query fat table in ClickHouse, you usually get performance of a few billions records per second. It is multiple orders of magnitude difference. The best case is when items table actually fits in memory, and you avoid creating hash table every time by using dictionaries or a join table engine.
Yeah, and by the way, external dictionaries support partial updates. It's not documented. Probably I can document and make some basic, very short explanation, because when I started to document it, it's very complicated. It's huge to document it for every layout. So, but you can actually do a lot of updates by a small portion. If you have like a huge external dictionary, like 50 gigabytes in memory and hundreds and millions rows in this external dictionary, you can apply only changes using partial updates. This feature is very old, from the March of 2018, and it's tested, and it's widely used in our company, but it's not documented. Yeah.
Mm-hmm. By the way, Joe said that he did not understand our answers, and maybe he needs translation. to
OK,
Chinese.
so 所以官方给的建议呢是建议使用字典表字典表能够比较好的一个解决这个维表更新的一个问题，然后使用字典表，然后有一个 dig-get function，可以用这个函数来完成你需要的这个类似于 join 的操作，就不需要 join，然后同时能够有很高效的进行那个商品表的更新。然后另外一个解决方案呢是使用外部表，可以用就是 dictionary 的一个外接的功能，比如说使用 Redis 的 dictionary， 这样你有一个 Redis 的这个集群或者 Redis 的一个实例来支撑你的商品表的这个构建。同样的接口也是使用的是 dig-get。So I think I have translated the answer.
Okay, thank you.
Okay.
Another question. Is there any way to count the total memory used by ClickHouse process and the backtrace? Can you control the upper limit of total memory of the ClickHouse process? The answer is yes and yes. This year, about half a year ago, we have added a feature that is named Memory Profiler. With Memory Profiler, you can collect stack traces from the places in code that allocated some memory when total memory started to be more than some watermark. So you will get memory profile that can be presented in a flame graph. Also, this memory profiler can be enabled for the server to control and to profile the total memory usage. Until recently, it was not be able to track all memory that is used by ClickHouse process. There were some memory that was not tracked, but it was significantly improved in the latest testing version 20.11. And the next part of the question, can you control the upper limit of total memory used by ClickHouse process? The answer is yes, but not quite. First about yes. We do best effort approach to calculate and account all the memory that is used by ClickHouse process. You can force the upper limit in configuration. It is named max server memory usage. But there is still some cases when memory can be over-allocated. We cannot do much about it. We can just implement best effort approach. So another question from Joe. Thank you very much for translation. I will check it out after the meeting. Okay, and thank you for your question. Another question is about range dictionary.
That's not a question, it's a statement. Just a suggestion that he used range dictionary to maintain a slowly changing dimensional table.
Yeah, that's a good suggestion.
Yeah.
So what else? Questions do we have? We have some questions to previous presentations. And the first question is to Nikolai. Nikolai, are you here? Do you?
Yes.
Okay. The first question is for you about explain query. Is it possible to show how many partitions will be used? Can it dynamically evaluate subqueries to estimate the number of partitions?
Well, now it is not possible to see the number of partitions and the names. Maybe I will add it later because it's useful information. And about subqueries, yes, they are evaluated for now, which may be good or not very good, because like if you have explained, maybe we expect that we evaluate nothing, but actually we do evaluate subqueries, and it may be needed just to understand how many paths do we read and how many threads do we use to work with.
But it is only for scalar subqueries.
Yeah, of course.
If you have join subquery in subquery from subquery, they will not be evaluated completely. They will be only estimated for query plan.
There is a feature request actually about number of partitions and about, so it's actually, I think it's very easy to implement, and when a query starts in ClickHouse client, for example, in the first row to show how many marks will be read and how many parts will be read from something like two partitions of 60, for example, or two parts of 100, something like that. And if you just press Ctrl+C and break the query, you will see on the first line these statistics.
By the way, this information is already available, and it is quite easy to get it. Just do set send logs level equals to trace. It is the setting. You just enable this setting, and you will get all log messages directly in the client. And these log messages will contain the information about index usage and how many parts will be read.
But it actually doesn't show of total, and it actually shows a lot of information, too much for me. Usually I need to see only how many marks will be read or how many parts will be read.
Yeah, so there is another feature request about collecting the statistics of distributed query and displaying it in ClickHouse client in nice form. For example, how many CPU time was spent, how many time was spent in I/O, in network communication. If I remember correctly, Amos Bird have some intention to implement it.
Yeah, but currently it's pretty naive solution that I use the HTTP handler to directly query the cluster based on the query ID we generated when submitting a query. So it's like we dump some URLs to the terminal, and we use that those URLs to continue submitting new queries to get the stats. By the way, I have a question to the explain pipeline. So we have a very nice progress bar to our ClickHouse clients. Will it be able to have those progress bar to somehow rendered as a pipeline?
So I can rephrase this question to Nikolai. We want to map progress bar directly to pipeline, so we will see what is the progress of every specific element of the pipeline.
Exactly. Yeah.
Oh, that will look cool. The only question how to show this progress bar. You mean we have pipeline which is like printed in separate place, and like we see in online how it is executed.
Yeah, we can see that the data actually flows through the pipeline.
Yeah, it will be a pretty cool feature, I think, for yeah, for dashboard maybe. Yeah, would be nice. Agree.
I'm pretty sure we cannot display it in terminal, but imagine it as HTML page with SVG animated by JavaScript.
Yeah, I agree that in terminal it is very difficult, but HTML page is a good way.
Is there any front-end developers in this room? It is a good task for you. I'm not front-end developer, but sometimes I just look at some JavaScript code that has to be built with Node.js, with NPM, with Gulp and Babel, and it just feels so ridiculous to me. So I'm not even pretend to be a front-end developer. Another question, not quite specific. Is there any optimization suggestions for join of 100 billion level dataset, 100 billion records? So the question is what join you are going to do. If you want to join 100 billion records table with another 100 billion records table, it will be difficult, but still possible. Still possible if you enable a setting named join algorithm, set it to auto or to merge join. This join will be slow, but it will proceed and it will finish successfully. Another use case, if you want to join 100 billion records table with just some dictionary table. And the dictionary table can have as small as millions records. In this case, join is not a problem at all. It will execute fine out of the box. You can even speed up it a little by using dictionaries or join tables. If anyone wants to add something, please.
Maybe I can add that if you need actually to join big tables and the second table actually, you should try to use local joins and shard the both tables and on the join key and yeah, to do local joins.
Okay. The next question is for Nikolai. So when query plan finds something optimizable, will it give any hint about what to optimize?
well, not clear which hint do we need. Like, I expect that maybe we want to see which optimizations happen in some like order, because there may be possibly a lot of them, and it is not clear if they are applied and in which order.
No,
Right now
the
it's only one,
question-
so
I think that the question is different. The question is about is it possible for explain query to automatically find some optimization possibilities so I can rewrite my query?
So maybe question that's like you want to write your own explain query, which will be more optimal than the current one.
No, the question is different.
Again, it's very difficult to understand.
It's about maybe the explain query is kind enough, so it will give the user advices on how to rewrite the query. But the answer is no, it does not.
Well, but if it can give user an answer, suggestions, then it can do it itself, mainly.
Yeah. But explain query can show you the optimizations, at least on pipeline or syntax tree level, that were in effect. It will just show you optimized queries and optimized query pipeline. But it will not give you the list of optimizations like their names and descriptions. Another question from Anonymous. Nested subqueries are slow. Is there any plan for optimization? I have to ask you, what do you mean slow? ClickHouse is not slow. You mixed up something. But if I'm going to be serious, I have to answer you, what is your query? What is your data set? And what do you mean slow? How do you measure it? What do you think how it can be faster? What exactly nested subqueries do you have? The question is unclear. You have a chance to clarify your question, and I will answer. So, what questions do we have? The question to Amos Bird about production usage in Quai show. How to rebalance the data when scale will increase or when it will decrease? How do you tackle this problem in Quai show?
So currently there are two ways. So for the HDFS cluster, we use buckets, and those buckets can be rescheduled to different instances, either increase or decrease. And another case is for the vanilla ClickHouse. If we don't do if we don't do pre-hashing based on some primary key, we don't control the old data at all. So the new data will spread across the new setup of clusters. But if we have the data spread on some hashing scheme, that won't work. So currently it's just to be done work.
Okay. Another question from Anonymous. ClickHouse is a big C++ code base. that have community. And it's not easy to control the style and the quality of the code. There are issues with memory, safety, memory management. Do you have any comments on rewrite in Rust? So about rewrite in Rust. We constantly rewrite our code from C++ to C++ to make it better, to make it perfect. We control the quality of our product, and I believe that our quality control is actually one of the best you can find across all open source code bases in C++. We have a continuous integration system that is available to everyone to look, to check the logs, the artifacts, and we implement every possible mean to control the quality. We use all available sanitizers. We use multiple different fuzzing engines. We use multiple different kinds of tests. We have small functional tests, large integrational tests of clusters. We have automated performance tests that can allows us to control performance regressions. And it allows us to control not only the memory safety of our code, because memory safety is only one of multiple possible issues, multiple possible things that we have to control. We also control logical errors, logical bugs, race conditions. And taking this into account, the idea of rewriting everything to Rust seems to be not viable. Not viable if we consider the amount of work that have to be done. But I'm pretty sure that Rust is very perspective and very promising technology. So the answer is no, but actually we consider that we can use Rust to implement some side functionality. For example, this is one possible way to approach user-defined functions. Suppose if we want to implement user-defined functions in memory-safe language to run them directly in ClickHouse memory, in ClickHouse shared memory. Maybe Rust will make it possible. Another question about user-defined functions. Any solution like Lua scripting or static library? Any comments? Currently, the only way to implement user-defined functions is to implement them directly in ClickHouse main code base. If you do that, just send us your pull request. We will help you with review. And hopefully, we will merge your code if it is not too specific.
I think that's another way to do it by the executable dictionary.
Yeah. That's very interesting way.
Yes.
And by the way, we have one task to optimize executable dictionary. So currently, executable dictionary will run a process and wait for finish of the process for every block of processed data. There is another way that somewhat resembles fast CGI technology. If you remember, probably you remember. Just run a bunch of processes and pipe data in streaming fashion. This is still to implement, but we consider to do it. Another question. It is slow to do multiple joins. Do we have some plans to optimize them? Do we have plans to optimize the join order? Yes, we have these plans, but for year 2021. It's a big task that is consisted of multiple small tasks. So it's a huge undertaking, but yes, we have plans to do it. Do we have query level cache? Or how to set the cache time for a table level? No, currently we don't have query level cache. And by the way, if I remember correctly, you can use chproxy product for this purpose. Yes, I think that query level cache is a good thing to implement directly inside ClickHouse. We already have one pull request that implements query level cache, but only for in subqueries. So most of the task is still to do. Currently, you can set up cache for source data. We have uncompressed cache, and you can use it to save the time on decompression. But it will improve performance of your queries if your queries are pretty light. So if your queries are already fast, they will be even more fast with this cache. Do we have any plans to do auto data rebalancing after changing the cluster configuration? Yes, we do. But it's not even for the first half of year 2021. It's in question when and if we will be able to do it. Actually, I'm quite optimistic. It's not easy to do. It's not easy to do if we will consider multiple different scenarios that we have. There are some approaches to this task, but these approaches are still in the beginning stage. By the way, ask ByteDance to open source their HA replicated merge tree. Maybe it will work for you. Most likely, we will have some difficulties in integration, and this will still be a huge undertaking to do. Joe, if you have some comments, please.
Yeah, we definitely will consider this to give some internal features and contribute to community, and then we can also get some comment from the community side, like Lexi, something like that.
Yeah, if it will be available, we definitely will spend the time and do the most that we can to integrate it to upstream.
Yeah, sure. I will think internally with like the team.
Okay. Another question for you. I see that you already answered this question, but I think it will be better to repeat the answer if, yeah, just to make sure that this answer will reach the destination. So the map data type seems to be interesting alternative support for very wide tables with more than 5,000 of columns to avoid creating too many files. But have you compared the performance of map data type and regular table with compact data parts?
Yeah, this question actually is answered in the bottom, the version deploy.
I can read your answer, or you can just repeat. I'm not sure that DJ have read the answer.
Yeah, so currently, because the compact, this big file is relatively a new feature, right? And so currently our version haven't included this feature. So so far we don't do the comparison. But after we integrate this new feature internally, then we can do this compare. I think it's a good idea to use the compact tables for the multiple columns, and so I think it's a good idea to use this, and we can do some compare on the performance part.
Okay, by the way, right now I will do the following. I will ask DJ to unmute, and he will tell us his takeaways after his experience with compact data parts.
Okay.
Hello?
Yeah, I can hear you.
Hi, everyone. Thanks for good presentation. Yeah, so we now use compact part till some small amount, but we are still testing on the, so we have another use case with like ultra wide tables, and there are some associated problems. And just, it's not about just select performance, it's also about insert. So it's not possible to create, each part will have like multiple files per column. So we're mainly experimenting with compact part, but compact parts themselves cause another problem, such as it becomes very hard to manage the columns, like if you add or remove columns, specifically removing columns, right? And so we're trying to see what could be the alternatives. And another problem actually is that with the growth of data and due to some regulation rules, right? So according to our business, there are some regulatory bodies that mandate to keep data, for example, for 5 years, but also the hot data is queried on a daily basis. So there is a need for some hybrid kind of partitioning, that the archive data is kept in some bigger partitions and recent data is kept in smaller partitions, because otherwise just there are a number of files on the operating system. It's simply more than any host can handle. And we tried, I don't know, so far I just tried on my local just to check what could be the options. So we do multiple table under merge, or different hosts hosting different data, like some hosts hosting old, some hosts hosting new. But we still see like this is a problem, but probably this is something that should be sorted on in the ClickHouse level. So if we check this map sounds interesting because we are able to create some kind of not entirely compact part, but some kind of chunk part. So for example, we know that, let's say 4,000 columns are static and they are guaranteed to be there, but we can add some columns and drop them, so the variable part. So there may be some evolution, we think. But yeah, compact parts are a big save, especially if it comes to we don't really see the big benefit on small insert. We see more benefit on the large number of columns and small partitions. It seems like it's a good use case for us.
Mm-hmm. And I strongly recommend to enable compact data parts only for smaller data parts. So inserts will be fast, selects will be fast, and alter queries will continue to be essentially free.
But when there is a drop, what happens if I drop column from the, and there are a lot of compact parts?
If there are a lot of compact parts, ClickHouse will have to spend some time rewriting it. Okay. But if you enable the threshold on data part size, there will be cannot be a lot of them.
Okay. No, but in our case, we were thinking to always use compact parts. So because there are a lot of columns in the table, right? So always use compact parts and just kind of ignore the old columns instead of dropping them. Maybe in some other databases, I think in Oracle, they support unused columns. So you can alter table and then set unused so that the column becomes invisible, but no action is made on the disk. That could be another alternative.
Actually, the large number of files is not a concern if you enable compact parts for small data parts, because you will not have a large number of large data parts.
Yeah, but our problem I'm trying to explain. So we have, let's say, queries that are frequently working on the daily level, right? So it's very frequently, so our data is typically partitioned by days, right? And there are, let's say, 5 years of data. And there is no simple way to make it hybrid, like, let's say, store the oldest 3 years as monthly or something like that. I mean, there are many ways, like merge table, distribute table, but there is no way to do it more or less natively. So yeah, we either have to have a lot of files or do some very operationally complex things.
Mm-hmm.
Is there any other solution? If there is any, we would be happy to know.
Actually, you should continue to test, and maybe you will find some sweet spot for the threshold.
Thank you.
So the next question is also from you. Any plan to support built-in arrays?
Yes, so, this from Amos Bird about this using JBots. So I assume this is this multi-volume feature, right? That ClickHouse automatically balance across multiple volumes.
Mm-hmm. Yeah, but JBot is similar to.
If I understand correctly, that there is a in progress RAID 1 implementation right now.
Yeah. Actually, it's not in progress, it's paused, but it was in progress, and now we have something less than a prototype. But we are going to continue, but this is of low priority.
Thank you.
And that's almost all questions that we have. We have another one about MySQL. It's also in Chinese, but it's about conversion from decimal to string. Amos Bert, could you please?
The question is that we lost precision when converting decimal to string.
No, we don't. For decimal, in contrast to floating point numbers, you don't get any loss of precision.
His question is specifically targeted about the data from MySQL to ClickHouse. So I'm not sure if it's related to the materialized MySQL feature or something.
I'm not 100% confident about MySQL, so I cannot answer this question. But what I expect is that conversion between decimal and string should be without the loss of precision both sides.
Probably this question about MySQL engine and that ClickHouse actually doesn't support direct translation from MySQL decimal to ClickHouse decimal, and it's using translation to a string on MySQL side and to a float type in ClickHouse side. Probably, yeah, it's not implemented. It's very easy to implement, but it's not done.
Yeah, if you convert true string from MySQL decimal to ClickHouse decimal, it is 100% safe. Precision is saved. If you convert into float, you will get precision loss.
No, I think that the problem that right now ClickHouse doesn't support decimal type for MySQL engine at all.
Yeah, I know. We have to implement it. This is one of many small tasks that someone have to do. Someone, maybe myself, maybe you.
Maybe you should create some sort of deadline queue for such small task and take one task which is already for a long time, for 2 years, for example, in this queue, and implement it.
That's a good idea, but it requires one little thing. We actually have to read and classify every of these tasks. And now I will check additional questions on YouTube. More questions in Zoom chat. And looks like we are done with questions. And what remains, I will do an experiment. I will allow everyone to talk. And everyone will be able to unmute and say something. You can say whatever you want. You can ask another question.
I want to continue discussion about map data type.
Okay.
So the problem, if you have 5,000 columns in ClickHouse, that you have a huge overhead in memory on insert, and probably it can be managed, and you have a huge overhead on files. So if, for example, you have 5,000 columns and 4,000 of them is actually empty, but files still will be created on a disk. So it's a problem because it creates a huge random I/O. And the map data type implemented in ByteDance, it's actually they have a limited number of keys in the map. So they created a limited number of files. And they limit this to not create a huge number of files. And the map data type, which will be implemented in ClickHouse, will store everything in one file. So it's understandable trade-off that if you have stored everything in huge file, it's very huge. It's very hard to read because this file is huge and you need only one key, one of 500 keys, but you have a overhead because you are reading the whole file. Maybe it can be created some implementation of this map type. So if part have a map type and this map has only 10 or 50 keys, probably 50 files can be created on disk. And if this part have a map type and this type, this map column have, for example, 2000 keys, maybe these keys can be stored in 50 files, a sort of bucket, and combine some keys into one file. Maybe something like that.
Seems it's more like a hybrid way, right? So instead of we have two. Either we store each key as a single column, or store all of them to a big file. And so, are you proposing a more hybrid way actually between these two sides?
Yeah, something.
Okay, so now we have pre-microphone part of our meetup, but only for those who are in Zoom. On YouTube, our meetup will end, and I would like to say thank you everyone who had a chance to participate on our meetup, who had a chance to watch us on YouTube. I would like to thank you all ClickHouse users, present and future users. We love you. Thank you, and I will stop the translation.